Hey guys, it's been a long time since I've built something with Golang and I've shown you guys on this YouTube channel. In this video, we're building a simple multi-microservice project. Now I use the word simple, but that doesn't mean it's easy. It's just simple in the sense it's not very complicated. We're going to be building multiple microservices. And before you build this project with me, you need to know that there are some prerequisites. You need to have intermediate to advanced understanding of gRPC, of Golang, especially of Golang, of GraphQL and Docker, because we're going to be using all of these things in today's video. And this video is not a basics video for gRPC, Golang, GraphQL, Docker, because what happens a lot on my YouTube channel is that a lot of viewers come and then they expect that I'm going to be teaching basics, but that's going to happen in this video. You need to know all these 4 things before you even start. So if you don't know these, please make sure you know all of this and then come back. You also need to know microservices concepts, in the sense, why are microservices used, what are microservices, how are they built. You need to know all of that before you even start building this project. Now there are multiple challenges with teaching a microservices project, right? And the thing is, it's a complex topic with little to no resources online, like about microservices. And it is an important topic because it's highly useful for building scalable and easy to maintain and manage software. Now, in 2022, I started a series which is still incomplete, which is the Monolith to Microservice project. The reason it's still incomplete is because I started this very too before time, in the sense I hadn't taught a lot of Golang stuff, and I started building Monolith to Microservice directly on my channel, and this confused a lot of people. There's a lot of you'll see on comments people saying, hey, I'm not understanding anything. That's because you were not supposed to build this project along with me if you didn't know microservices. And I realized that there's not enough good resources online, so that's why I went back. I went back in 2022, went back to my series, which is the 55 projects playlist for Golang. And I built a lot more projects, right? So at that time it was like just 15-20 projects, and now I've built like 55 projects of Golang on my YouTube. So make sure you check out that playlist. There are 55 projects of Golang, and by now I've covered Go in a lot of details in that playlist. Not basics. I expect you to know basics before you do that series, but you basically build and you understand Golang in motion, in the sense how do you use it in the real world. And I've also covered multiple databases in detail, like MySQL, Postgres, MongoDB. All of those databases have been covered in detail, and how to work with them in Golang. And then I've covered how to work with Go in Docker. I've covered gRPC, I've covered GraphQL with Golang. I've covered all of this, and all of this is going to be useful in today's video. And now I feel I'm ready to teach microservices. Now I'm ready to teach microservices because I've already taught all of this, and I can give you resources to go back. In case you get stuck in any of these places, I can give you resources, or you know by now that there is a playlist, and you can always go back to those resources to check out more stuff in detail. Okay, so now is the right time for me to teach you microservices. I couldn't do that in 2022 properly. Anyways, this is what we are building now. So I also request you to be cognizant of the fact that I'm not going to go into too much detail on each of these things like gRPC and GraphQL. I expect you to know all of that already. And I'm going to talk more about the project rather than about each of these technologies, and I'm not going to take a detour and just go into each of those because then this video will never ever end, because it's going to take hours and hours. So this is what you're building. We're building a multi-microservice project, as you know, and it's going to be very e-commerce-ish. I won't say it's an e-commerce project. It's like e-commerce-ish in the sense I've taken like some interactions that happen in an e-commerce project, and I've taken like a project out of that and I've built it. So you have an account microservice, you have a product microservice, and you have an order microservice. So these are the 3 microservices we have, and each of these microservices has its own database. That's usually when I build microservices, I follow the database, like per microservice per database pattern, where you have a separate database for separate microservice. You don't have to do this. You can like club databases also, or you can have just one database, all microservices calling that database. You can have multiple patterns, and I will probably show different patterns but this is like the safest way to build microservices. Okay, so our order microservice has its Postgres database, product microservice has its Elasticsearch database, account server has its account microservice has its own Postgres database. And since we're going to be using gRPC, the reason we're using gRPC is obviously to make things more scalable and faster. And we have a GraphQL gateway API. I like GraphQL, even though I mean it's very simple to use, and even though a lot of people don't use it, but it's like the people who use it, they swear by it. It's very simple to query, simple to run mutations on. And yeah, so we'll have a GraphQL gateway where we'll have like our mutations, our queries, all of that stuff, and all of that's going to hit a gRPC client. So the respective gRPC client for account, for product, and order. And the client's job is to share data with the server or call the server, however we're gonna call it. And then the order client is gonna have interactions with the product and accounts, because an order, to create an order, you need product and account data also. So there will be some cross communication and cross calling of our interactions with gRPC. So this is essentially what we are building, right? And so we are also going to have multiple Docker containers. There's going to be a different Docker container for GraphQL, different Docker container for account, different one for products, different one for order, different one for the database of the account microservice, which is the Postgres, different one for the product database, which is Elasticsearch for products microservice, and different one for the order microservice, which is the order DB, Postgres. Okay, so we have different containers for all of these, different container for the GraphQL server also. Now this sort of a combination, this kind of a setup makes the project extremely scalable, because you have different containers for different things, and you can scale the containers as you want. So maybe you think that the account microservice is getting a lot of traffic, you can just scale it, start scaling it much. It's very easy. And so our Docker compose.yaml file is going to have details on all of these all of these containers. But then we'll also have a separate Docker file for each of these services. So the GraphQL will have its own Docker file, the catalog will have its own Docker file, account will have its own Docker file, order will have its own Docker file. So in case you don't know what Docker Compose is, how to write Docker files, please make sure you go back to the drawing board, you learn all of that and come back. Our GraphQL is going to have two things, queries and mutations. This is how GraphQL servers are built. You have queries which help you to access data or get all or get by ID some particular data. In our case, it's going to be products, accounts, and orders, because these are the three microservices we have. And this, obviously, as you know, is going to query the database and going to get the information. And mutations are for updating something. So for example, creating an account, creating a product, and creating an order. That's what mutations are for. So we're going to have queries, a separate file for queries, separate file for mutations, and all of these different mutations in this file, and all of these different queries in this file. That's how we're going to have it. Then we're going to have services, right? So the order microservice will have these services, which is the post order or the create order service, or the get orders for a particular account service. And the account microservice will have these three services: the post account or create account. Post is basically the method. It's essentially creating an account, or essentially creating an order, and post is the method. And then you're getting a particular account, which is with the help of the ID, and getting all the accounts. Similarly, with the product microservice, you're going to have post or create product, get a particular product, and get all products. We're going to build this project together. We'll do all of this together, and hopefully, like after all of this is built, I will share the project on GitHub as well. But don't count on it. Because I'm shooting this video now, and this will go to the editor, and then I will upload it. I don't know when all of this will happen. So just don't count on it. Make sure you build it along with me. This project is supposed to be built along with me. It's not to be, but yeah, I will try to make sure. Sometimes I forget, sometimes I have to travel, something urgent comes up, and I'm not able to put it on GitHub on time. So don't be worried by that. Just build it along with me. All right. But I'll try to share it. No problem. So services, and then you have the project structure. So you have this is how we're going to organize our project. So we'll have the microservice, project, and each microservice is going to have a CMD folder which will have the main.go file for that microservice. This is going to be an auto-generated folder. If you work with Protobuf and gRPC, you know this folder is automatically generated for us along with this file pb.go. Gonna have the Docker file specifically for that microservice. Gonna have a client.go file. Gonna have a server.go file. Client and server are for the gRPC repository to work at the database level with the database, and then you have the service.go and the SQL file, which is for the database. Okay, so this is what the project structure is going to look like. This is for each microservice. So it doesn't matter if it's the accounts microservice, the products microservice, or the orders microservice. They'll all follow this kind of a structure. You might not appreciate right now why this is important, why having similar file names and similar type of structure in all microservices is important, but it becomes very, very important once your project starts scaling and you have, like, let's say 50 microservices soon to start working with. So not only are the file names important and the way the number of files and which files are there, that's important, but also the way you've written the code inside those files, that's also very, very important, just for maintainability, because once the project starts scaling, it becomes very difficult to maintain if it's not been organized in a very, very repeated manner. And what happens is, now I'll share something with you which happens quite a lot in companies. Let's say you're a team of few engineers working together, and there's another engineer who'll come, he'll say, oh, this another microservice also follows the same project structure and the code looks very similar. Why don't we just club them together, right? Wouldn't that make it easier to manage? And you'll get this advice from a lot of not advice, I'll call it like just a suggestion from many developers that, hey, why don't we just combine everything and that completely beats the purpose of a microservice. Microservice basically means that you have to have separation of concern, like everything is separated, even though you'll see a little bit of repetition between the code and the files, but it's supposed to be separated. It's completely all right. There will be some side effects, which is like a little bit of code will be repeated. Don't listen to that engineer who says combine everything together. Okay, he doesn't know what he's talking about. All right, so we have a quick understanding of what we're building. Now, very quickly, I'll just talk about my 6 AI plus Golang projects, which is an advanced project. So if you want to take up a challenge where you want to build like really high quality production level applications using AI and Golang, then I have this project which is live on Gumroad. The link of this will be in the description of this video. Make sure you check it out. You can check out these awesome reviews that we have on that course. All right, and this is the content. So you build a AI Discord bot, you build a Whisper API bot, a Telegram AI bot, Kubernetes AI assistant, Terraform AI copilot, and a very powerful and comprehensive terminal AI assistant. So you build all of these things, and it's 26 hours of content, extremely detailed planning exercise for each project. Now, if you think this is a detailed planning exercise, you have to check out this course. You'll understand how deep I go into each detail before I even write a single line of code. And all the code is well documented. Each line of code is explained in the course. So make sure you check it out. I have some really good reviews on the course. Make sure you check it out. All right. So now that we have all of this out of the way, it's time to start building our project. We can start. I'll open my terminal window and we'll get started. So I've opened up my terminal. I'm going to create a directory go gRPC GraphQL Microservice YT for YouTube, and I will cd into it, and here is where we say go mod init github.com/akhilsharma90 /go gRPC GraphQL Microservice. All right. So here, what we're going to do is we're going to open this up in VS Code. and we have our go.mod file there, which we expected. Now, if you remember the diagram that I just showed you, I said that there will be multiple microservices, right? So we have a account microservice, we have a catalog, or our products or catalog, same thing, catalog microservice, and then we have our order microservice. For the GraphQL API, I'm going to have a separate folder called GraphQL. Okay. Now, one more thing that I want to tell you is that I'm going to be making a lot of mistakes when I code, when I build this project, and that's completely all right. I have a very casual way of building projects, and I also suggest you also have the same. Like, don't take things too seriously when you're building things out. It's almost like if you've done painting, or if you've done art or painting, anything like that. When you paint, you paint in broad brush strokes in the beginning, and then you take a thin brush and then you create those details. That's how I like to work. That's how I work. What ends up happening is many people who are very precision oriented from the beginning, they look at me writing all this wrong code, and then they will comment saying, hey, I didn't understand this, and they'll just close the video and run off. Don't do that. Don't run off, because I will correct all of the code. This is just how I work. This is how I've always been building, and I've been around for a long time. I know probably that's maybe not how things happen now in 2024, but I've been doing this since a long time, right? So this is how I've been doing it. I've built projects that have scaled to multi-million users. I've run a tech services firm. I'm currently the founder at Armor AI. We're backed by some of the best investors in the market. So don't get fooled into thinking that you always have to write perfect code from just the beginning. What's really important is having clean planning, and then you start building. And I say this because I've led teams, I've mentored developers, and the only thing that I tell them is don't get too caught up in writing perfect code from the beginning, because that will create a block. That will create like a writer's, writers have this writer's block, and it comes because they start thinking, they start getting anxious because they want to do everything perfectly. Don't do that. Write, create project, all of that, and then make fixes later on. All right, now, because I do this in public, so I get a lot of hate for doing this, but please trust me, this approach really works. This is how experts also do it. And yeah, so you have all of these 4 microservices, all right? And then, as you know, here around here, we also gonna have the Docker file, all right? And the Docker file, I'm not using anything fancy. I'm just using Docker Compose. Usually I use, whenever it's microservices, I use a lot of fancy stuff. I get the Kubernetes and all of that stuff. But like I said, this is a simple microservices project, so I want to keep things simple. And we're gonna have a lot of services here, right? You know about the services that you're gonna have here. We're gonna have a account service, as you can see here, account service. We're gonna have catalog. So whatever you see here, you're gonna have that. Okay. Now the other thing I suggest is having 2 screens. Maybe you have a laptop and then another screen, or you just have 2 screens like me. And on one screen you have the diagram open. So this is what I'm always looking at. Let me show you what my other screen looks like. This is what I'm looking at, right? Because this is almost like a map. So as you start drifting away from the map, or you forget what you were building, you're gonna have problems, right? You won't know, like you'll drift. You'll start drifting, right? So make sure you have the map always open. You know what you're building, what you're doing. So I have all of this open, and I'm just gonna keep looking at this repeatedly. Keep, I'm gonna now create all these, I'm just creating this file now, and I know that it's gonna get linked to all of these files, and I want to have these different files in different folders, right? So make sure you have that open on a different screen. All right. So I have the account service, I have the catalog service, and I have the order service, and I have the GraphQL service, right? I have the account DB, right? And how do I know that I have the account DB? Because of this, because I have the account DB service, I have the products DB and orders DB. Okay, so we're just following the diagram. Okay, so I have the account DB and I have the catalog DB and I have the order underscore DB. So if I'm putting an underscore here, so I'll just keep things consistent. I'll just put an underscore here, underscore here. Makes it easier to read. So this is my Docker compose.yaml file. Now, many times while writing a Docker compose file, I do make mistakes with these spaces. Okay, now one more thing about me is I don't use a lot of extensions. So you wouldn't see something that's correcting my code or GitHub Copilot, something like that. And to all the extremely senior engineers that I mentor, people who are technology heads at companies, what I tell them is to not let their engineers use a lot of those plugins also, or somebody who's interviewing for those companies, I tell them to not use extensions, because once you get dependent on those extensions, you start getting into a lot of trouble. I don't say that you shouldn't use ChatGPT. So if you have access to ChatGPT, just put in your Docker compose.yaml file, ask it to check it out and make corrections. That's completely all right. But once you start getting dependent on extensions, there's a lot of problem, because you won't have access to those extensions when you're appearing for interviews, and that can be a lot of challenge, right? Because imagine, like, all of your programming career you've been using extensions, and suddenly you appear for 10 companies in a row and they have this interview process where there are no extensions allowed, which is basically the process for all of the important companies, right? They don't allow extensions, so you're going to be in a lot of trouble. So so that's one more thing that I would like to just point out. So when I make mistakes with these spacings, because YAML files are sensitive to the spacing, I use ChatGPT. I go to ChatGPT, I check it out. And when ChatGPT wasn't there, like till 2 years back or 3 years back, or like 2 years back, I think, yeah, when ChatGPT wasn't there, I would just look at it with, for a long time, and then I would fix things, and I just, kept trying it out, like Docker compose build or up, whatever the command would be. And I would then fix it manually, right? So now we just have a faster way to fix it. But I know that even if ChatGPT wasn't there, I would be able to fix it. So having that confidence, so I would just suggest, like, do it 2-3 times without ChatGPT, and then just use ChatGPT all the time, so that at least you can do things if you don't have access to ChatGPT sometimes, right? Not that important maybe, but yeah, if you want to be just a well-rounded developer, you might want to listen to this advice. All right, so these are our services, and I will come back to this later. And now in my GraphQL folder, right? In my GraphQL folder, I'm going to have its own, like all of the folders will have their own Docker file. So I'm going to say app.docker file, okay? And it's gonna have, GraphQL has its own YAML, so it's gonna have GQL gen. I'm gonna use a package for generating our some GraphQL files. So I'm going to use GraphQL generator.pyml, and this will have the graph.go file. I'm going to have the main.go file, and I'm going to have models.go. And like I mentioned, GraphQL has two things. One is the queries and the mutations. So both of them going to have their own resolver. So I'm going to say query resolver.go, and I'm going to have mutation resolver.go. And I'm going to have schema.graphql. So schema.graphql, all right, where I'm going to put the schema for all my GraphQL queries. I'm going to just go ahead and close all of these files. Okay, so yeah, that's how it's going to be. And so in the queries, I'm going to have a get all accounts query and a get all products query. These are two queries that I'll have. And then I'll have the get all orders queries, because we have 3 microservices, so we have we have queries for all of them, like getting all the products, getting all the accounts, getting all the orders. For order, the thing is you need the account ID. That's how, because orders are associated with account ID. So that's why I'm going to have a different file for it altogether for that particular query. So I'm going to say account resolver.go, and this is going to have my orders query. Okay, so my accounts and products queries and my orders query is here. For my mutations, I'm going to be able to create an account. I'm going to be able to create a product, and I'm going to be able to create a order. What I'm doing right now, now there are multiple ways to build a project like this. One way would be you build a small logic and then you test it and you see, okay, everything works perfectly fine. I don't work like that in many cases. The way I work is I build like a skeletal structure, like almost like a mind map. So you're thinking of how the project is connected to each other, how it's built. So you create like the foundation or the scaffolding around the building, and then you start working on the building. That's how I do it. So what I'm doing right now is I'm not working on a logical piece. So for example, if I was working on a logical piece, I would first write everything in the main.go file, and I would run that server. I will check in the terminal, okay, the server works, or everything is fine, nice. That's how you would see most tutorials structured up until now, right, on YouTube. That's how you would see them. The way I do it is that I think from a user's perspective. The user is going to run a query to read all the products and read all the accounts. The user is going to create put a query for creating the accounts, creating the products, and order. And also the queries and the mutations are linked, because only if I have the accounts and products existing in the database, which will happen with the help of create accounts and create product and create order, will I be able to run queries on them. So they're also linked. So I'm just working in a very mind map kind of a manner, rather than a logical, building a logical part and then testing it instead of that manner. Okay, so I just want to clarify my approach. And now this is right. So now when I have these mutations and these queries, now what I'll do is I'll start linking them to the microservices. So what I'll do is I'll have the corresponding functions or the ability to be able to execute this in the create product in the catalog or the product microservice. So I'll have that there, like working with the database to be able to create the product. So I'll start closing off all of these threads that I've created. That's how I approach things. Now that we have our little bit of our scaffold in place, what I want to do is I want to work on the schema.graphql file. So when you're looking at this diagram, you're thinking of one way to think about it is that this is a module, this is another module, this is another module, and this is another module, the GraphQL gateway. And right now, in the beginning, right now we're working on this module. So I want to do as much as possible on this module till it makes logical sense, right? And then once I've done enough on this module, I'll jump between all of these modules as well. That's how I'm thinking about this problem right now. Okay, so for the schema, what I've done is I've created the schema here. This is how I plan a GraphQL schema. Now, a GraphQL schema, in case you don't know, is just the schema at the GraphQL level. It's not the actual schema in the database of the microservices. That means that this is just what your GraphQL server is expecting, that how your queries and mutations would be structured and what kind of fields they would have. But this is not the actual schema or the actual fields that go and get stored in the database, right? So the GraphQL level, it can be like very wide. It can have some extra fields, it can have some extra details, not a problem. But this kind of matches the actual schema, but doesn't have to be the same, right? So there are two things when you define a schema. One are the types, the other are the inputs. Now, as you know, in the schema, there are two things that are important. One are the mutations, and the query, so that the GraphQL server understands that the user is going to send this mutation, like for example, something to create an account, create a product, or create an order. So the user is going to send these kind of mutations, right? Because the user wants to create these. And when you're creating something or updating the state or changing the state of the server or the database, that's called as a mutation, as you might know by now. And the query is just read only. You're just wanting to read the values. So I want to query the accounts and the products. Okay. So those are my queries and my mutation and query. Okay. So these are the two important types, my mutation and query, but there are more types. So for example, there is the account type. I'm just defining at the GraphQL level what my account is going to look like. So it's going to have an ID, name, and the orders. My product is going to have ID, name, and description, and the price. My order is going to have ID, name, description, and price. And my ordered product is going to have ID, name, description, price, and quantity. And my mutation and query you already know. Okay. Then I have something called as inputs. Inputs are like, for example, if I want to create an account, what do I need to send to the server? I need to send at least the name of the account. That's how I'll be able to create the account, right? So this is what the input for the account when I'm creating an account and when I'm sending a mutation. This is the least stuff that I have to send. Similarly, with the product input, I'm sending the name, description, and price. The order product input, I'm sending the ID and quantity. And the order input, I'm sending the account ID and the products along with it. Okay. By order input, I mean when I'm creating a new order. Okay. By product input, I mean when I'm creating a new product. Like these three: create account, create product, create order. And account input means I'm creating a new account. And then we have some advanced queries which will have pagination. So pagination will have these things: ID and name, and the orders. And then the product input, order input, account input, we have seen already. This is the ordered product input. So the product that has been ordered, for that, this is the schema. Okay. So this is completely our schema, types and inputs. And all you have to do now is, once you have this in the diagram, all you have to do is now just go ahead and recreate that in code. So let's see what it looks like. So you have your schema.graphql file here. Okay. And like I've always mentioned, you keep the planning board always open. At least that's what I like to do. Earlier I used to do it on paper, but now I used to use crayons, however you want to pronounce it. Multiple ways to pronounce it, right? So I use that for planning, or I use a board like the one that I just showed you. But I always like to keep that in front of myself. All right, so the schema.graphql. So I start with this scalar time, and I create my first type, which is my account. Okay, and as you can see on my other screen, the first type is the account. Okay, and the account already I've noted that the account has an ID string, name string, and orders. Then I have product. For product, I'm going to need ID, I'm going to need name, I'm going to need description, I'm going to need price. Then I have order. For the order, I need the ID, the created at timestamp. So this is why we had to import time here. We had to refer time, and then total price and products. I just realized that I have a typo here, so I'm just going to completely update this here, because my order is based on the products and accounts, and I want to have those details here. So I'm going to have the ID, I'm going to have the created at. I'm updating it because I intend to share this diagram with you guys. And there's the total price of the order, okay, which is float. And then you have the products. All right, so ordered product. All right. So that is my order. All right, now the diagram seems updated. So that's my order, and then I have my ordered product string, and ordered product also has name, description, price, and quantity. Okay, name, description, price, and quantity. All right, and then you have the pagination input. You have skip and dig. You have the account input. Then you have all these inputs, like the product input, the order product input, and the order input. So let's create those. So I have the product input, just copy this, copy description, copy the price. That's my product input. Then I have my ordered product input, so I'll just make a copy of this, and I'm just going to remove, I'm just going to put ID and quantity there. And then my order input is going to have the account ID and the list of products. And then finally we have our mutations and queries, which I like to keep at the end of the sorry for the noise. I've started drinking water in these sipper bottles. It's just easier to drink faster rather than like a regular bottle. You might find it weird, but it's actually very very good for the teeth. At least I've realized that if it's a glass bottle or a metal bottle, it just keeps hitting my teeth a lot. Anyhow, so you have create account, and then you have account input, and you have create product input, and then you have create order. All right, and then I'm just left with my query. Now the benefit of creating a schema GraphQL in the beginning itself is that you will be able to run this GraphQL generator command, and then you'll get your models generated and also your generated.go file. I'll show you what this looks like once I have created my queries. So I have my accounts, and then for my advanced querying, and then my products. All right, so okay, so this was it. This is our schema.graphql, and now we'll run our command to generate the generated file, the generated.go file, which I need here from my GraphQL schema. So let's go ahead and do that. First, what I'm going to do is I'm going to have something in the I'm going to have to write something in the GraphQL gen YAML file, and this is my project. Okay, let's go gRPC GraphQL micro YT. Okay, so this is my project, and then you have the fields, orders, resolvers, equal to true. All right, and my GraphQL schema is already ready. I have my GQL gen.yaml file. This is required by the package, the GQL gen package. So let me first import it here. Require github.com/99designs/GQL gen, GraphQL generator. And I'll just say go mod tidy here. Okay, what this error means is that I need to mention the version number, which is what I've not done here. So I'm going to go ahead and mention the version number. And now I'll try to run this. Okay, so now I don't get any errors because it's removing it. I need it because I need to be able to run that command, the GQL gen command. But it's removing it. Anyways, because because I have not used it anywhere, so that's why it's thinking that. So I don't need this package, so it's removing it from my go.mod file, which should be all right. Let's see, because I have to run this command, and this is the command. Let me find it. I have it written somewhere. Yeah, this is the command. So it's go run github.com/99design/GQL gen, which is the name of the package, and then generate. So it's saying no required module provides package. Yeah, so this is exactly what I was doing. I was trying to add it directly to my go.mod file, but let's see if it still lets me add it there. Yeah, now I'm able to add it. But usually if I just add it there and run go mod, that also is usually fine. But then I have to import it somewhere. Anyway, so now it's going to get it. So I'll just run it again. Okay, so it's saying schema.graphql not found. That's because I'm not in the right folder, and I have to switch to the right folder. The right folder is GraphQL. So I'm just going to go run, generate. Okay, there's something wrong in my schema.graphql file on line 6, undefined type order. Okay. Undefined type order. All right. So let's look at the diagram and see if we're doing things right. Okay, yeah, one thing you have to notice is that the first letter is capital always when defining a schema. So I think that's the problem here. Definitely that's the problem here, but there could be more problems. Let me at least fix that and run it. Unable to build object definition, unable to find type. Okay. So this error that we just faced, one small reason for that is that the name of my folder that I've created is go gRPC GraphQL micro YT, but in my go.mod file, this is the name of the project, which is, it's actually go gRPC GraphQL Microservice. So if the name of the folder is what you're putting here, then that's wrong, because you have to put the name of the actual module, which is this. So I'm going to go ahead and make that change. And the other thing is, it's asking for GraphQL.account. It's looking for that. And what I realize is I've not defined my account model. So I'm going to go ahead and define that. So I'm going to say package main. And I'm going to say type account struct. It has an ID, it has a name, and it has orders. String, and order. When we receive the query for the account, sorry, the account spelling is wrong. When we receive the query for the account, it's going to be in JSON. In JSON, I won't have capital ID, it'll have like small ID. That's why you have to mention the JSON versions as well. All right, so this is my model, and now I'm going to go ahead and try to run that same command again. And let's see what happens. Yeah, so it works perfectly fine, but it was working, but validation failed. Account resolver so it's mostly to do with the account resolver, and it was expecting package, but it found orders. So let's fix that. Now before I go ahead and try to fix the issues in the account resolver file, I just want to tell you that the generator.go file which I wanted has been generated. Okay, and it says code generated by the package 99design/gqlgen. It gave me the file that I needed. Okay, and it's based on the gqlgen.yml file and the schema.graphql file. And based on the models.go, you also get modelsgen.go. What I'm going to do is I'm going to remove this, delete it. Okay, I'm going to delete this also, and I'm going to fix this. So here I'll just remove this orders, and I'll just write package main. Okay, and same with my graph.go. I'm just going to go ahead and write package main. My main.go is also, of course, package main. Models.go already has package main. and my mutation resolver. I'm going to remove this, right, package main, and my query resolver. Okay, so I have all of this, and I'll just go ahead and create the file again. Okay, now it says go dot some entry missing, blah 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 blah. So it was asking me to get, so the error basically was, it was asking me to get the latest version of GQL Gen, which is 0.17.54, and that's what I did. Go get github.com, the latest version, and it added that now. So I've added the latest version of GQL Gen, but I'm not sure if it'll still run. Let's see. Yeah, everything works fine now. Okay, so I have the generated.go file, and it looks all right to me. But if, let's say you make some changes in your project, it's completely all right to delete the generated.go file and the model generated file.go file. It's completely all right. You can always delete them, and you can fix them later on. And regenerate them, basically, is what I mean. All right, so now that we have that, now what I want to work on is the graph.go file. Okay, because the graph.go file is like the central file to the whole GraphQL API gateway, and this is gonna have my new GraphQL server function. Okay, and it's gonna have my server, which is a struct, which is with the help of the server, I'm able to call the three different clients, like the account client, the catalog client, and the order client. And why am I telling you that, and why does that matter? So let me show you again. From the GraphQL gateway, I'm able to call these three clients: the account client, the product client, the order client. And those in turn have gRPC connections with these servers. Okay, so that's what I'm trying to say here. So my server is going to have three things. One is the account client, the catalog client, and my order client. Okay, and I'm going to keep all of this commented out at the moment. And this function, the new GraphQL server function, it takes in three things. It takes in the URLs of the servers. So it's going to take in the account URL for these three microservices. So catalog URL and order URL. All of them would be strings. Returns the server or an error. Okay, and here for the account client, to be able to create the server, because we want to return the server from this function, right? So to be able to create the server, I'll define the type. So this will be account dot client, this will be catalog dot client, and this will be order dot client. And here, because I need these three things, right? The account client, catalog client, order client. For the account client, I'm going to call the new client function and going to pass the account URL, which I've accepted, which I've received in this function. For the catalog client, I'm going to hit the catalog.newClient function and going to pass the catalog URL there. And for the order client, same, I'm going to hit the order.newClient function and I'm going to pass the order URL there. Okay, And all I have to do now is handle these errors. So I'm going to handle it once, I'm going to copy and paste it then after that. So error is not equal to nil. Okay, return nil, comma, error. And just copy and paste that for all of these. The order is dependent on both the account client and the catalog client, and the catalog is dependent on the account client. So here I'm just gonna say account client dot close, and here I'm gonna say catalog client dot close. And the server just returns, sorry, this function, as you know, returns the server. So we're going to return the server, and the server is going to have the account client, the catalog client, and the order client. For the error, we're returning nil as of now, and this is our new GraphQL server function. Alright, so we created a new GraphQL server function, and we returned the server from this function. Now in my graph is like the map, right, for the GraphQL API gateway, and this file has everything that's going to happen with the GraphQL API. So it's going to have some mutations, some queries, so I'll just go ahead and create those. So function mutation. So the function is called mutation, and it's going to return the mutation resolver, and returns the mutation resolver, but with a small m. And when I say mutation resolver with the small m, I'm talking about this mutation resolver. And this file is going to have, that means something called as a mutation resolver. It's the struct, right? And the mutation resolver resolves mutations, in the sense there are multiple mutations, like the create account, right? So if you refer to a diagram, if you refer to our diagram, we have create account, create product, and create order. So these are three mutations that I need. We're going to go ahead and define them. So function mutation resolver, create account, takes in context, and account input. Now if I'm creating an account, I need account input. Account input is basically this thing that we created here, and returns the account, because once you create account, you're obviously going to return the account, or you're going to return the error. Okay, and I'm going to keep this commented out, of course, but I'm going to just copy and paste, because there's going to be my create product, and there's going to be my create order. Okay, and in create product is the same. I have my mutation resolver, my context, and instead of account input, I have product input. And instead of getting an account, I get back the product. For my create order, it's going to look similar. Mutation resolver, create order, context, and the input. The input, instead of the account input, it's just order input. Instead of your count, it's order. So all three are really similar. Okay. But the only thing is, I'm going to keep these commented. I need this because obviously in my graph file, I have referred to that. So going back to my graph.go file, this is my mutation resolver. Then I have my query resolver. So I'm going to say func and create this method called query. I'm going to have query resolver. And since we have orders linked to the account, so like which account has placed which order, so we'll have something called as an account resolver also, and we're going to work on that as well. So I have return query resolver. Now this query resolver is here, and I have not defined it yet. It's again, it's a struct just like we created for the mutation resolver. So type query resolver, it's a struct Now you'll notice that these two files are showing errors because they're trying to I think refer to the server, and server is something we've defined here, but it's commented out. So what I'll do is I'll just remove the comments here, and now these errors have gone away. So now back to our graph.go file. We have our query, and then I need my account resolver. So I'm just going to copy and paste this. It's for my account resolver, and return account resolver. Account resolver is something again that we have not defined, so I'm going to go to my account resolver file. I'm going to define my struct, which is my account resolver. Now back to the graph.go file. Finally, I'll have a function called toExecutable-schema. Here, this should be in the previous line. Okay. So just like I defined the functions in my mutation resolver, I'm just going to go ahead and define the functions here also in the query resolver. So if you refer to the diagram, you have 3 queries. You'll be able to query all the products, you'll be able to query all the accounts, you'll be able to query all the orders. Now for the products and accounts, I'm going to have that in the query resolver, the products and accounts. But for the orders, because orders are also dependent on accounts, so I'm going to have that in the account resolver file. So in my query resolver, I'm going to have accounts. So it accepts all these things, which is the context, the pagination, and ID, and it returns slice of accounts or error. So that's the accounts, and I'm going to keep it commented out, but I'm just going to copy it because I need to create the products query. So accepts the context, pagination, query. Instead of ID, you'll take the it'll also take the query. So I'll say string, and it'll take the ID. And instead of the account, it'll return product. So that's our products query. I'm going to copy this. I'm going to go to my account resolver, and I'm going to create the query for the orders. So instead of query resolver, it will be account resolver. Instead of products or accounts, it will be orders, and here we'll have the context, and then we'll just have the object which will have the details on the account. Instead of product, we'll get back the order. And I'm gonna just go ahead and comment this out. What I'm going to do is I'm going to just keep all of this commented. Sorry. And now at least the GraphQL folder doesn't have any issues. Now the entry point into this GraphQL service is our main.go file. So we should work a bit on the main.go file. And the first thing I'm going to create is the app config, which is a struct. And this has three things: the account URL, the catalog, and the order URL. It has a main function. The account URL, we'll have access to it from the environmental config file as account service underscore URL, and this again we'll have env config as catalog service URL, in my main function, I will create a variable called configuration, which will be of type app config that I just created here. So my configuration variable will have all these three things: account URL, the catalog URL, and the order URL. I'm going to use environment config dot process. and I'm going to handle the error. And the purpose of the main file is to call this function, the new GraphQL server function. So the new GraphQL server function takes in the account URL, the catalog URL, and the order URL. And if you remember, that's what our graph.co file, the function new GraphQL server function, is accepting: the account URL, catalog URL, and the order URLs in string format. Okay. So we'll get our server back. We'll get a GraphQL server which will be in S. We'll be able to access it with S. So here, if you remember, we created a function called toExecutable-schema. This one. That's the one that we're calling here. Now, we don't have some access to something called as handler, so it's able to import GraphQL handler for us, and that's perfect. At the same time, we're able to get log, net/http, and environment config. Now we have http.handle/playground . So if you've worked with GraphQL before, you know that when you start a GraphQL server, you get something called as a playground. And on that playground, you're able to run queries. So you get like a UI, and you're able to run queries or mutations, and you're able to interact with the GraphQL server. And with the help of that, you're able to interact with the with your server and the database. So it's saying handler.graphql is deprecated, switch to GraphQL/handler.new. So it's asking me to remove this because it's deprecated. So it's saying use handler.new, and here it's saying use playground handle.playground. So that's what I will do. That's what I'll do. So I'll say handler.new default server, and I'll say playground.handler. Hopefully this should not lead to any problems. So while I'm happy with the refactoring, and playground.handler looks all right, but for handler.new default server, I think it's getting in GraphQL/playground for me, which I don't think I need. So if I just say new, does that still work? Yeah, no, I think playground, it's getting playground because of this only. And let me just go back to how it was earlier. Yeah, so it's saying handler.graphql isn't accepted. Use handler.new new. I'm just going to use handler.new. That's it. And it says handler.playground as a problem, so use playground.handler. Okay, no problem. So now at least our main.go file looks all right. Now in the main.go file and go.mod, you see that there are some errors. And I think they're to do with these packages that I've imported here, but they're not part of go.mod. So what I'm going to do is I'm going to go ahead and just run run main.go, and it's going to tell me to get these packages. So that's what I'm going to do. So I'm going to add this, and then I have to add this also, and I have to also add the handler. I'm not sure if my internet is working. It is. Okay, so it was able to add this. Then I'm going to go ahead and add this package. And finally this package. Yeah, sorry, not finally, because it's showing there's one more package to be added, which is the nconfig package. And finally this one, the nconfig package. So once you've done that, most of the errors, like all the errors from go.mod have gone away, and many of the errors from main.go have gone away. There must be something that's like not defined, so I'm not gonna go crazy over it, but I just need to be aware what the issue is. So I'm just gonna just run it just to see. So it's saying new GraphQL server is not defined and handler.new is not defined. I mean, handler.new is something that they only asked me to add, and then the new GraphQL server, I think there's something wrong with the spelling, because in graph.co, oh yeah, so I'll just remove the comments from here. So now is the same spelling as new GraphQL server. It looks like it. Okay. So there's no way really to get rid of the errors without completing the other things as well. Now, when I made when I removed the comments from this part, since I'm calling account, the count module, catalog module, and the order module, Golang is thinking that I'm probably calling it from Stripe, but I'm actually talking about the modules from here: account, catalog, and order. Those are the ones that I'm calling. Now, to make these errors go away, I can go to the account module, catalog module, and order module and create the new client functions, which with the help of which it's getting these clients. But then that will, once I do that, I'll end up making some more things that would need even more things, and then the errors would stay. So usually what I do is I end up completing the entire project, and then I test, and then I fix all the issues one by one. That's how I like to go about things. And so for now, we can keep all of this commented out for the time being. And it's okay, so we won't think too much about the error in main.go where it doesn't know where new GraphQL server is. That's completely all right. And what we'll do now is we're gonna focus on this, at least this error, because if you remember, I also got the handler.new is also undefined, and from the documentation I can see that there is new default server, and if that's still an issue, let me see if it's still an issue. Yeah, it's still undefined in the handler. So we'll have to find, or should we just go back to what we had earlier, which was handler.GraphQL. And even though it shows a line here, it's deprecated. It doesn't give an error at least, and the error is only with the new GraphQL server. So until I find something for this, I'm gonna keep it like this, and I'm just gonna focus on this later on, which I know where the issue is, which is coming from the graph.go file. It's a function that I need to define. So what I've done is, as you know, I've removed comment from just this first line and the last line, and then I've removed comment from return server because it's going to return the server. And now main.go file has only one issue, and that would be at this part, to executable schema. For server also I've commented out everything else inside, but these, the function outside, the struct outside is uncommented. So the issue is going to happen because of this function. So once I do that, graph.go gets a new issue. It must be something in here. But if I run it, I'm still getting new GraphQL server undefined. And that doesn't make any sense because new GraphQL server is already here. But that's all right. So the thing is, we'll have to complete a few things in account and catalog, and then we can come back, we can try and wrestle with this issue. I don't think it's a big deal, and we'll fix it together, so not an issue. So for now, I'm going to leave this as is, okay? And I'm going to work on these three clients. So account client, catalog client, out client. So I'll close all of this, and I'll go to account first. In the account folder, if you remember from our diagram, from our project structure, we're going to have a CMD folder, and this is going to be auto-generated, and then we're going to have these files. So what I'll do is I'll at least create these files. So the first folder is the CMD folder, and the CMD folder has another folder inside called account, and that has a file called main.go. At the account level, we have the Docker file for the service. I'm gonna have the client.go, I'm gonna have repository.go, server.go, service.go, and the SQL file and the db.docker file. So let's check it out. So we have the CMD folder with the main.go file, and then we have the Docker file, client.go file, repository, server.go, service.go, and the SQL file. And in addition to this, we just had the db.docker file also. Yeah, so we have all these files now. Now in like I mentioned, these files will be there in, like most of the files will be there in catalog and order as well. And what's important here is to understand the relationship between these files. So this is how the relationship goes. So first is you'll receive the mutation or query at the GraphQL level, okay, which we have created here, the GraphQL file. Okay, we'll receive the query or mutation here, and it'll go into the mutation resolver or the query resolver. And from the mutation or resolver or query resolver, what's going to happen is you're going to end up calling the client of the particular service, and this is why we have the clients here, because that's what we're going to end up calling. We're going to end up calling the clients, and from the client of that particular service, like for example, if it's the catalog service or the account service, from that client we'll call that server. From that server we'll call the service of that the service file of that microservice. From there we'll call the repository, and the repository is doing the database level operations. So this is how the flow of control is going to happen. Okay, so I'll just open up. And so what I like to start with is from the bottom, which is the repository, because once I write something here, it's going to refer stuff in the repository. Once I write something here, it's going to refer to stuff in the service. So it's great to go like this. Okay, that way you avoid errors, and also you're building from the base. You're building from the foundation up to the building. So let's do that. So in the repository.go file, what I'm going to do is I'm going to call this package account, and all the files obviously will mention package account. And my repository will be an interface, and we'll have put account here, get account by ID, and list accounts. And then I have the Postgres repository struct, where I have access to the database, which is, in my case, is sql.db. And so we have this struct called Postgres repository, but we want to create a new Postgres repository. Takes in the URL as string, returns the repository, or it returns the error. And here in our interface, this put account is going to have context dot context comma a, which is the account, and error. And get account by ID is going to take context, and also it's going to take the ID. And list accounts. Here, instead of ID, we're going to take skip, which is for the pagination. It will be uint 64. Skip a take. And in this case, we were returning a particular account because we're getting an account by ID. In this case, we're going to return a collection of accounts. And the new Postgres repository, we're going to call the sql.open function, And this opens up a connection to our Postgres database at the URL that we've accepted here for the Postgres database. And what gets returned is the database itself, and with the help of the DB variable, we're going to access the database later on. And what I would like to do here is handle the error. And we're going to just ping the database to see if the connection has been established or not. Okay, so really straightforward, opening the connection to the database, pinging the database to see if the connection is open. And then we're doing all of this to be able to interact with the database at the repository, from the repository. So repository file is at the bottom, is responsible for all the database operations. And then you have, on top of that is the service, the server, then you have the client. The client is basically being called from GraphQL. That's how the interaction is happening. And because this function is called new Postgres repository, it's supposed to return repository. And what we'll say here is return Postgres repository. All right. So now let's define some methods. The first method is for the Postgres repository struct. The first method is the close method. This closes the connection to the database when we are done. Then we have the ping method, which we have just used above. Right, and then we have these methods: the put account method, the get account by ID, and the list accounts method. So let's create those. So the put account method as we know, it takes in context and the account, and we also know that it returns an error, so that made our job easy. And similarly, the get account by ID method, I'm just gonna write func before that, and then the list accounts method. Okay. So we have the outline for all the methods from our interface, and for the put account, we can start now. As you know, repository can work at the database level. That's like, this is the last line of control, and this is where the actual database operation is going to happen. So what I'm going to say is r.db.exec context, and here I'm going to have my actual database command. So my database command is insert into accounts database, ID comma name, and then the values, and I can refer to those values with the help of $1 comma $2, and then I have a.id, a.name, and I can just return the error. Okay. Then Here I'm returning the error, but I'll have to capture the error first. So error is equal to, and we don't, when we are creating a new account, we don't need to return anything. If there's an error, only the error. So that's why I don't need to return the new account that was created. So I'm just keeping a dash here. Then you have get account by ID. So here I'm gonna have one more database level function, which is select. So this is like a SQL command where you select the ID comma name from accounts where ID is equal to $1, and by $1 I mean ID. Now, because I'm supposed to return an account from here, from this function, so I'm going to create a variable and initialize it as account. And this is empty, obviously, because there's an empty account in the beginning. a.name error comma nil, and we return nil comma error, and here you return a, which is the account or the error. Now for all of this I'm using the database.sql and context packages, and I'm also going to be using the Postgres library, which I've created multiple videos about. Sorry, the PQ. Then for the list accounts, I'm going to return the collection of accounts, and here I'll have rows comma error is equal to r.db.query context dot select ID comma name from accounts, order by ID, descending, offset $1 limit up to, and then you have skip and tick. And this error we might receive here, let's handle it. So if error is not equal to nil, return nil comma error, and you're going to refer rows dot close, and your list of accounts, because you're supposed to return a slice of accounts from here, so you're going to create a list of accounts. So your accounts is an empty list of type account, and so you're just finding account by account and appending them to the list of accounts that you want to return from this function, and that's what's happening here. So I'm going to use the append function to append to my accounts collection each singular account that I'm getting access to, because I'm using rows.scan, so I'm able to access all the rows one by one, and I'm just appending them to my accounts collection, and then I'm just going to send the accounts collection. checking for error here. So if error is not equal to nil, return null comma error. Okay, so that's our repository.go file. Now that we have the repository, we can build service and we can refer to everything that we've built in repository. So I'll close this for the time being, open up my service. In service, I'm going to say package account. And I'm going to have my import statement open here because it'll automatically import the thing that I'm needing, I'm going to be using. And the service, just like repository, is an interface. And what's there in the interface? You have post accounts, you have get account, and you have get accounts. So exactly the same thing as repository, which is put account is the same, right? We're creating a new account, and get account by ID is the same as get account, and list accounts is the same as get accounts. So these three things, they merge, they basically call those three functions from the repository. So three service functions calling three different repository functions. Okay, it's just done to keep things really clean, from server flowing to service to flowing to the repository. This is what your service interface looks like. And this is going to accept name and return account, okay, because post account, right? And then you have get account. This is going to accept the ID and return that particular account. And here you're going to return the list of accounts. So here there's no name, there's skip uint64 comma take uint64 and returning a slice or a collection of accounts. So that's our service interface. Now account as a struct, this is what it looks like. It has name, it has an ID. So the name is of type, sorry, the ID is of type string, so is the name. And in JSON, we're going to receive ID and with small I and small d, and here you have name with a small n. And so you have your account service first, which is a struct, just like you had a struct for your Postgres repository. So you have your account service, which is a struct, and repository. And you will now, because you have a struct called account service, you would want to have a function that initializes it and returns a new service. So you have a new service function, accepts repository and return the service. And then you just have to define these three functions, three methods I meant: post account, get account, and get accounts. So I'm going to copy and paste from here. So just the only thing to be added here is, since this is a method, of the struct account service. So I'm going to just say account service here, and similarly for these as well. Okay, and in the post account, where we're supposed to be creating an account, what we're going to do is we're essentially going to call this the put account function. This is essentially what we have to call, because this is the function that's actually going to create a new account in the database. So that's the function you have to call from here. And dot put account function. Okay, so we're exactly following the script. Service, each service function calls another function in the repository. That's what we're doing. So we're calling the put account function here, and just like that, we're gonna call the get account by ID function. Okay, and just like that, we're going to call the list accounts function. So quite straightforward up until now. I hope there's no confusion, because we're following a very simple approach. So first you initialize an account. Name is what you've accepted, what you've received in the function as a parameter, and the ID, I'm going to use this package called ksuid dot new dot string. So once I save it, I still don't see the package that I'm using, so I'm going to get it here. Like add it manually. So I'm using the ksuid package to create a new ID string. Here we're passing the context and the account, because we want to create that account, right? So from GraphQL, if you remember, from the GraphQL schema, the input for a new account input, is just a name. That's it. So we accept just name when we are building our at the GraphQL level, and that's what we're accepting here, just the name, along with the context, of course, just the name. But the account struct requires ID and name both. So name we are setting to what we got, and ID we're creating with the help of the ksuid package. And this whole thing is an account, and this is what we are passing to the repository, the function in the repository, which is the put account function, which accepts an account, and it's basically adding that account at the database level. All right. So you have put account and you have error is not equal to nil, return nil comma error, and here we will return a comma nil. Right, so here you have get account, and in get account we're going to return get account by ID function, takes in the response from the get account by ID function, which takes in context and ID. So the get account by ID function just takes in context and ID and returns an account. That's it. And we're returning an account from here. And our function list accounts from repository takes in context, skip, and take. So here we have context, skip, and take, these three things. And here is just some pagination code where we're checking if take is greater than 100, then skip is equal to 0, and take is equal to 0, take is equal to 100. All right, so that's our service. And we have our repository now, and we have our service as well. And now we just have to create those functions at the server level. So you'll see that we create those three functions, the post account, the get account, and get accounts at the server level also. And those functions are going to call the functions at the service, and the service is already calling the functions in the repository. Right, so this is a great visualization, this is a great way to build. And let's go back here, go to our server.go file. Sorry guys, I had to take a short break, and also I've changed my t-shirt. Anyways, so we were working on the server, and on the server also has to talk to the client. So what you can expect is the server is going to call the functions in the service, but it's going to return gRPC format data also. So there's going to be a stream here. That's the thing we have to remember, okay? That not only will the server call functions that are defined in the service, it's also going to return data to the client in the form of some gRPC protobuf data packets. So this is how we're going to do it. This belongs to package account. All right, and then you have your I'm going to have to define the gRPC server, and I'm going to have the gRPC server code, both the gRPC code both in the server.go and the client.go file, because they are the ones that are connected to the gRPC. And now I have to create the functions that call my service function. So for example, I have to create the equivalent of post account, equivalent of get account, and equivalent of get accounts. So three functions I need to create. So one is the post account, then I have the get account. I'm going to keep the same names between the server and service, same name of the functions, and get accounts. So for the post account, this is basically a method for the gRPC server struct that we just created. And post account takes in context. Type context dot context. And PB is protobuf. We haven't created that file yet. We'll create an account.proto file, and that will belong to the protobuf package. And here we're gonna have something called post account request, but I'm gonna leave it empty because we haven't created it yet. So it's gonna be the request, and in the what we return from this function is the response. So we're gonna refer to the request here for the account and the response here for the account. But since we haven't created those yet, so I'm not going to refer to them here. And then we're going to have the error. Okay. And essentially like I said, what I'm doing is I'm just going to call the function, this function here. So I'm going to say s.service.postAccount, pass in the context and r.name. What you get back is the account, and I'll handle the error also. If error is not equal to nil, return nil comma error. Okay, and like I mentioned, I'm not just going to call functions here. I also have to like I have some responsibilities when it comes to protobuf. So I'm going to be returning something here. So it's going to be pb.post account response. I'm going to keep it empty now. Yeah, so I'll just keep everything empty for now, but that's what I'm going to return from here. Okay. And for get account, I have again to define the function. This is again a method, and this again takes in the context and the request for the get account. This is going to be the post account request. This is going to be the get account request. This is going to be the post account response. This is going to be the get account response, and an error. And here again, instead of this post account, I'm going to have get account. And instead of name, I'm going to pass ID because I want the account to be returned based on the ID. And then from here, for the protobuf, I'm going to return a get account response from here. So here we had the post account response being returned from here. Here we'll have the get account response being returned from here. I'll define it further after a while once I create the account.proto file with you guys. For get accounts, we'll do something similar. Yeah, so here also we'll have the get accounts request. Here it'll be the get account request, here will be the get accounts request, and I'll just create that very quickly in a while. And then we'll come back to this, and here we'll have the get accounts response also. And essentially what you're going to do here is this exact same thing, and you're going to return something from here, and also you're going to call the function from service, and the function is called get accounts. Of course, this one, get accounts function. And it doesn't just take context, it also takes R, which has the get accounts request, and then you have the get accounts response and the error. So everything looks all right. And now it's time to create our protobuf file so that we can come back here and fill in all these blanks. So the protobuf file is going to be called account.proto, and if you work with gRPC, I'm sure you have worked with gRPC, we're going to use that account.proto file to create our PB folder, generate our PB folder, and the account.pb.go file will be generated with that as well. In the server.go file, I need one more thing, which is the gRPC server. So even though I've defined the struct, I've not created the function for listening to the gRPC, because the server, as you know, is going to listen to gRPC messages. gRPC service, and on which port will be listening on messages, and that will be an integer. And I'm just going to use the net.listen function from the net package to listen on a specific TCP port, and I'm going to pass my port here. Okay, and if error is not equal to nil, we're going to return the error. Now I used the gRPC package. Let's see if it's able to find the gRPC package for me. It wasn't able to do that, so I'll have to do it myself. It's the Google Golang or gRPC. I've created multiple videos using this package on my in the 55 Golang project playlist series. So this is the one that we are using, the gRPC, And from gRPC, with the help of gRPC, you're going to create a new server. And I'll be able to access that server with this serve variable. Then I'm going to use my register account service server function, which I haven't created yet. So I'm going to leave this line empty. And I'm going to use something called as reflection to register the server. And reflection is it was able to get the right package for me. This is the reflection package. And then I'm going to return serve.serve lis. So this will basically start the server, the gRPC server, and start listening on the right port. Okay. And here, like I said, I'll leave a line empty here, pb dot something something, and then there will be I have to pass the server here and the gRPC server. So I'm just going to leave this empty for now. But yeah, but this is the server.go file in essence. Now all of this, right, the pb dot stuff, all the pb dot stuff that we have been not working on up until now, that comes from that. I haven't done that because I haven't shown you what the account.proto file looks like, and and I wouldn't want to use those functions because that would end up confusing you. So let's first create those functions. Now a proto file is what defines how this particular microservice is going to interact with using protobuf with the gRPC server. And using this file is what is how we'll create the actual protobuf file. So this is like the human generated file, like we have to write this, the proto file, and then the computer generates the .pb .go file for us, which has like a lot more information, just like we did for the GraphQL generator, right? And here the syntax we are following is called proto3. Package pb. This and the everything that'll be in the pb folder, that the pb folder will be created for us. All of that will be package pb, so we'll be able to access everything easily. And that's why when you see here what I was doing in the server.go file, I was saying pb dot something, because I'm trying to access the pb package, and I'll have to import it here also. So here when I go to account.proto again, a proto file consists of requests and responses. Like with the gRPC server, you would either send requests or you would get back a response. Now the request would be formatted in a particular way. By formatting, I mean it'll have a particular number of fields, and we'll have to define what fields would they be. Similarly for response, there would be some fields that we'll have to define. Now there will be, for every action you take, you'll have to define the request and response. So for example, in our since we are in the account microservice, right, most of the requests and responses would be around account. So there will be a post account, like creating a new account, there will be a request for that, right? So if you want to create a new account, there's a request for that. So somewhere we must have, so here, like as you can see, we have defined these functions post account, and here we are going to accept a post account request and return a post account response. And I'm going to do that with the help of this once I'll have to define it here. So there's a post account request, and the way you interact with gRPC is using messages. So that's why we define it like a message. So there's a message for post account request, there's a message for post account response. And then and all you have to do is just look at the server.go file, which has your get account and get accounts. So we need two more requests. Sorry, we need 2 more requests, 2 more responses. Okay, so the other request we need is the get account request. So we'll say message get account request, and get account response. then we're going to have the get accounts request and get accounts, which is multiple, like getting the list of accounts. So I'm going to define that also, get accounts request and get accounts response. All right. And then I'm going to just define my service, which is the account service, which has all of these things that we just defined, which is the RPC post account, which takes in the post account request and it returns the post account response. Straightforward, right? Then I have my other RPC. Sorry, this bracket closes here. And I won't leave a space for this. And I have my other RPC, which is my get account. For that, I'll have my post account request, which returns my post account response. And then I have my RPC get accounts. Sorry, here I've just made a mistake because this is get account, this is get accounts. So here it will obviously be get account request and response. And here will be get accounts request response. Yeah, so everything seems okay to me. All we have to do now is define how these messages are going to look like. Before this, I'll define a message for the account itself. So this is what an account would look like. It'll have a string, and it'll have string ID, and it'll have a name which is also string. And when we say 1 and 2, we basically giving them unique fields. That this is like a serialized message, right? The first field would be ID, second field would be name, just like how serialization happens. This is what we're telling it. And then you have the post account request, and here I just need name. And post account response, here I just need the account. And get account request, what do I expect when somebody wants to get a particular account? What will be in the request? They will just have the ID in the request. So I'll have just ID is equal to 1. Sorry, my throat is acting up. This happens when I have to sit for hours and do this. And then you have the get account response. So here you have your account equal to 1. So account, as you can see, is of type account, which we have defined here. And then we have our get accounts request. So when you're getting multiple accounts, we have pagination, right? We have skip, and we have take. And I'm gonna say both of these are uint 64. Skip will be the first one, take will be the second one, right. And get accounts response, repeated accounts, there will be accounts 1. So this is what my proto file looks like. Okay, and what I can now do is I can go to my server.go file and just fill in all the blanks. So for example, here, this thing that I left empty is I'll still leave it empty because this is going to require something like the register account services server, which we'll have as part of the PB file that's created. But here right? These ones I can start filling up because these are just the post account request and response. So what I'm going to do now is I'm going to say pb dot post account request. In case you have questions about how I have so much clarity about you know, all these post account requests and responses and all of that, is because if you look at my other screen, I've just brought my other you know, screen here. You see that I've also planned that out on the board. Like, I didn't show you this because this is like, I just keep doing a lot of rough stuff also on the board. So everything is kind of planned out. So I've already planned out the requests and responses on the other screen. That's what I, you know, like I have it all nailed down to the T, just to ensure that I have to do as less thinking as possible while coding. And because once you have like a visual map, like a road map, visual map, then you are just following the map. You don't have to do a lot of thinking after that, right? So that's how I have this, like, a lot of clarity around exactly what I'm doing right now. And then you have the post account response. But I've also seen that many people are not visual thinkers, like in the sense they don't need to see so much stuff visually and then write stuff. But in my case, I just want to know how things are linked and where exactly I'm headed. Maybe it's a personal thing, but I've also seen like large teams also do this. They're able to easily collaborate very well if everything is laid out visually rather than just text documentation. Okay. So at least in the pre-development time, like once you've built things, then you can just write documentation. But if you've not built stuff, then you need a lot of visual guides. That's at least what I believe, and at least how I've been working. All right, and here you have the get account request. So here I'm going to say get account request, and here it's going to be get account response. Similarly here as well, it's going to be get accounts request and get accounts response. Sorry, accounts request, accounts response. I don't see it in the I didn't see it in the list, and I think that's because I made some mistake here. Is it get accounts request, get accounts response? No, it feels all right. Everything looks okay. Get accounts request, get accounts response. Everything is fine here, but why didn't it show up in the autocomplete? I don't know, but I don't think I've made any mistake here. All right, so coming back to my server.go file, here when you see these functions, they were returning something, right? They were returning something, return pb dot, and I didn't complete them because we hadn't created our proto file yet, and we didn't know what was going to be there in the proto file or the protobuf package. And here, when you see in the post account function, what you want to return is the post account response, because that's what this function is returning. So it's going to be straightforward. It's going to be just the post account response. And the post account response, according to proto, post account response has account, right? So that's why I'm going to put an account here. And account is pv.account. That's the message that we had defined. This is pv.account, and that has an ID, because if you look back at the account, it has an ID and a name. Both are strings, so ID and name. Okay, so that's my post account. Now for my get account, I'm going to return the get account response, this one. And I need to be mindful of what the get account response looks like. It just has an account. let's do that. So pb dot get account response, and inside this you have the account. So pb dot account id a dot id comma name is a dot name. And for the error we have just put a nil here. And now the get accounts, here we have to return the get accounts response. So I'm going to go here, say pb dot get accounts response. Now the problem is there are multiple accounts, right? That's one little problem we have. So we'll have to create a collection of accounts. And how do you do that? You refer to pb package and the account defined, that account message defined in the pb package, and you create an empty account first, but a collection of them, empty collection, and that's your accounts, empty collection. And now you're going to range over the response here. Okay, range over the response. Till now what we were getting back from these from the service methods, we were capturing in A, and that's why we were able to access values from A up until now. Here I'm just going to call it response because you know, just range over it, so it just makes it easy for me to see that variable. That's about it. And accounts, and we're going to append just like we did earlier. We're going to append accounts, and each account is what we're going to append to the collection of accounts. And each account we have ID and name. And so for my get accounts response, I'm going to return the list of accounts which I have in my accounts variable, comma nil. So there you have it. You have the server.go file. You have the service.go file. Server.go file, one thing is pending, of course, this part, which is going to call a register server function. But I think before I write that part, I'll just use the account.proto to generate my my PB folder. Now we have added these packages to the project, and what I haven't done is I haven't run go mod tidy yet. So I'm going to say go mod tidy. It's going to go ahead and get all the packages that I've been adding, but you know, that haven't been added to the go.mod file yet. So I think it's done doing that. And now that we have the account.proto file, and I want to create the PB folder, what I'm going to do is I'm going to go ahead and go to the account folder and run my go generate command. So it's saying go generate command not found. So I just realized I don't even have protobuf because I changed my WSL system. I keep changing from time to time. So I need to have protobuf installed. So what I'm going to do is I'm going to get protobuf. So this is the command that I used, wget. And on app, if you're on Apple, it'll be different. It'll be like it'll be brew command, but on Ubuntu this is what it looks like. It's a wget command to get protobuf. You can just Google how to get protobuf or ask ChatGPT, and it'll give you this command. So you just run it, you get protobuf, and then I'm just gonna unzip it. Okay, and then we're going to move it to another location. That's it. And now I have to install 2 plugins as well. So I install one plugin and another plugin. And this is what the project looks like now. Like I didn't have to install Proto-C and all of that here in the folder itself, but I forgot to go out of the directory and install it. So it's all there in the folder itself, and that's completely all right, not a problem. What I need to do now is get the path right. So I'll just set up the path. So I say export path $path go and go path/bin. And now I will be able to run the go generate command. But before that, the command that I was trying to run before, I have put that command in my server.go file. This is the command here, the go generate command. And now all I have to do, so this is the command basically, in case you want to check. And what I have to do now is just say go generate. And now it's saying account.proto line 3 expected this. Okay, so account, now it's able to help debug the error. It's helping me debug my errors, and there should have been a semicolon here. Unable to determine go import path for account.proto, please specify either blah 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 blah. So let's see how to fix that. So even after all those steps, I was still getting a lot of errors. So what I've decided is I've removed all the plugins and Proto-C that I had installed here. I've removed all of that, and I'm gonna do all of this from scratch with you guys, so that you're also able to follow along, and there's no confusion on how to generate the PB file. Now the first thing is we have to build the PB folder on our own. So we just create the PB folder. That's it. And everything else inside this folder will be created by running the command. So I'll just write here, create the PB folder in your project. Okay, so I've written down all the steps here that we need to run one by one to be able to generate this file. Generate the files inside the PB folder. So let's go ahead and do that together. So I'm at the root location in my Ubuntu WSL. I'm in the root location, and the first thing I'm gonna run is this wget command. I'm going to include all the steps that I showed you in the readme file, and I'm going to try to upload this project as soon as possible after this project is over, after I've created the video. But in case there's a delay of like 1-2 days and you can't wait, just note down these commands. By note down, I mean that if you go to Google, you will find these commands anyways. But what I'm essentially doing is I'm just getting Protoc or Proto-C 23.0.1, the Linux version of it. If you are on Mac, you will just need to do brew or something like that. Okay, so now this .zip, like Proto-C 23.0 Linux .zip has been saved. All I have to do now is unzip it. So I'll unzip this zip file. So I'll put the command for unzipping it. I've unzipped that now, and there is a Proto-C file here inside this unzipped folder, and that file I want to move that to my user/local/bin, and I've done that now. Now there are these 2 plugins that we need to be able to run Proto-C properly, and I will now install both of them. But installing them is not important. You also need to check the path. So I'll just echo my path, and I will export the path just to be sure, and I will so that I don't have to restart my terminal. I'll just update the bash rc, and then you have to just create the PB folder, which I have done now inside the account folder, as you can see. Right, so it's all inside the account folder. I have a PB folder now, and in my account.proto file, if you look at the README, in your account.proto, you have to add this, which is option go package, blah, 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 blah. You have to add this thing, and you go to account.proto and you basically add this, that the extension for the file. And in my server.co, I had written this command, but this command is not working for me. So what I'm having to do is I'm having to actually run the command on my terminal. So I'll just run that final command. This is the command proto C. But this command you have to run inside your account folder. This is where you have to run it, and I'll run this command and I don't get an error, luckily. And now when I go to my PB folder, I see that the files have been created for me. Okay, so that's awesome. Everything works perfectly fine, and now I can continue. And now I can continue my server.go file. I wanted to complete this, right? In my server.go file, the what I have to write here is pb.register account service server. So all of this is coming from the pb.co file that was just created, and that's how the autocomplete is working. And then my gRPC server, sorry, and that's it. And now I'm going to quickly check if everything is fine with this file. Yeah, so this is I have all the right packages, pb, and then I'm also using fmt and net. So there's an is equal to sign missing here, sorry. So I'm also using fmt and net. It was able to get these two packages for me, and this seems to be wrong. So if I remove it and if I hit save, everything seems fine now. Okay, and if you just quickly check, everything seems to be all right. I have the get account method, I have the get accounts method, but obviously it still has this one error which it's showing out here. Not a problem. We can handle that later on. As long as you have the service sorted out, you have the server sorted out, repository sorted out, things are looking good. And now I'm going to focus on these three things. So account.proto is also sorted out, and because of that you also have this file now. So now I have to focus on the main.go file, client.go, and then these two Docker files, and that should be quite straightforward and easy. What I'm going to do first is I'm going to focus on the main.go file. For the main.go file, you start with package main, and we'll be importing a few packages here, but I first start with config. In my config, the thing I need to run this particular microservice is firstly my database URL, right? And from my environment configuration, it's going to look like this: database underscore URL. Then I have my main function. I create a configuration variable, environment config dot process, and I'll handle the error. If the error is not equal to nil, log dot fatal error. Okay. Now I'll create a variable R, which is of type account dot repository, and I'm going to give a forever sleep of 2 seconds. So I'm going to use a time package and the second method of the time package. And here I'm going to use account dot new Postgres repository to create a new to start a new repository and basically a new connection to the database. So database URL for our microservice, and here we'll also handle the error. So if error is not equal to nil, return and close the connection to the repository. And now we'll just start, we'll just print out that the server is starting on listening on port 8080 for this particular microservice. And using account, we can start a new microservice, new service, and also listen on the gRPC on 8080. And this listen gRPC function is defined here, but we're just calling it from main.go. So now we have started the gRPC server, and we have connected to our database URL. These are the two things we have done in this particular file with the help of repository and the help of new service and listen gRPC functions. So we have done these two things. That's what was required from main.go file. Main.go file doesn't do anything else. That was it. Let's just see if it got the right package. It got retry and config. It was able to get account, and it was able to get log and time. So that everything seems fine to me. Now comes the client.go file. In the client.go file, we just need all those functions that are going to be called at the server level. So for example, an equivalent function to post account, equivalent function to get account and get accounts, all these three. So how do you do it? You say package account. That's how you start. You import so this client that I'm creating for account is the same client that I end up using here in graph.go. When you see in the server, the server for GraphQL is very different from server from each of these microservices, right? Each of these microservices, the server is the gRPC server, whereas for GraphQL, the server is something that's helping you access the clients of these three microservices. If you remember the diagram, the GraphQL server makes requests to the clients of these three microservices. The clients then go ahead and make requests to the servers of those particular microservices with gRPC. Okay, so these are the clients that we are creating right now. So we're creating the first client, which is the account client, and this client is a struct. It's able to connect to gRPC. Sorry. So this is gRPC.client connection. And this is pb.account service client. Everything to do with pb is, as you know, in the pb folder or the pb package, which account pro also belongs to. And here, first things first is, now that we have a client struct, we want a function that helps us take a URL and initialize a connection or initialize a client. And it basically returns a client. That's how it initializes the client. And the way it does this is that you first use gRPC to dial on that particular URL. And I will also handle this error. So if error is not equal to nil, return nil, error. And C is equal to pb.new account service client, then the connection, return, and I'm just going to return the client with connection, C, nil. So this is what my new client function looks like. Then I have a function to close the connection to this client, c dot connection dot close. And now those three functions that I was talking about, that we need to be able to call three respective functions in our server. So the first function is the post account function, then we have the get account or the get particular account function with the help of an ID, and then getting all the accounts, or the get accounts function. So the function is basically just it's a method of for the struct client. So post account takes in context, which is of context dot context type, takes in the name, which is of type string, and because it's post account, so it returns an account which is referring to the account struct. That's why there's a star, and c.service.post account. So all that you're doing here is calling the function in the service, the post account function in service, and sending a post account request, which requires a name. So if you remember the post account request we created here, post account request, it requires a name, as you can see. That's exactly what we're doing. Here the bracket would look slightly different. This is what the bracket would look like. And I will also handle the error. If error is not equal to nil, return nil comma error, then return ampersand account id r dot account dot id comma name r dot account dot name. All right. So this is what my post account function looks like. Now, while writing this, I just remembered that when I was trying to start my GraphQL server, I was saying go run main.go, whereas I just now realized that graph.go file also belongs to the main package. That means that I would have had to say go run and space dot instead of go run main.go. I just realized that both of these are in the same package, even with models.go and everything. So what I can do is I can go back and I can go to the GraphQL folder. There's the GraphQL folder, right? Oh yeah, I have to first exit the account folder and go to the GraphQL folder. And if I say go run, instead of main.go I say dot, it should run the all the files in the package main. But it still won't work. But I'm just telling you that, you know, at that time I didn't realize that all of them were in the package main, so that's why I was saying go run main.go. There's still some issue, and I don't really care because I'm gonna fix all the issues anyways once I'm done. But the main things are working, right? So we were able to create the generate the GraphQL file, the generator.go file from the GraphQL schema, and we were now able to generate the PB, all the files in the PB folder with the help of gRPC also. So these two things I was concerned about. If they work, everything is fine. I just have to now complete these functions, and then I will work on the other two microservices, and then it's time to start fixing things properly. Now, a very quick point that if you've reached this far into the video, you must know about this community, which is my Discord community for my YouTube channel. This is where we discuss a lot of AI, a lot of cybersecurity, a lot of blockchain, Rust, Golang. So there's a lot of discussion going on for all of these things. We hang out here, we talk about stuff, and I also help people. So make sure you join this community. Make sure you participate actively here, because there's also a lot of jobs that people keep posting, right? So make sure you join this. Just a great place to network, grow, learn a lot. All right, now quickly just back to the video. The link for that Discord community is in my profile, is in my YouTube profile, so make sure you join it. And yeah, now back to the video. So we were at post account. Now the get account function. The get account function is also a method. So I'm gonna get this quickly here. And so is the get accounts function. Just take some context. And returns an account. And here I'm calling the get account function from service. And I might encounter an error while doing this, so I'll handle that error also. So here we'll say if error is not equal to nil, return nil comma error. And return the account ID is r dot account dot ID comma name r dot account dot name. All right, and here comma nil. Then the get accounts function. First thing is context dot context. Then you have, so if you remember, when we're getting multiple accounts, that's like a list of accounts, right? So we have pagination there. We have skip and take. Take u int 64. Sorry. Account and error. And here the point of this function is to call the service function called get accounts. And in the get accounts function, you'll get back R and error, but they won't be capital, of course. Here I'll handle that error. So if error is not equal to nil, on nil comma error. And now this is similar to the get account function, where we're passing in context and the get account request is being passed. Skip has the value skip, which we've just received as a parameter, and take has the value take. All right, and now we'll create our collection of accounts, because that's what we have to return from here, a collection of or a slice of accounts. So accounts, an empty collection of account is what we'll create first, and we'll range over all the received accounts, right? So we received all the accounts, the response in R, and those are the accounts we want to range over. And the final accounts has your list of accounts plus this new account, the account that you just ranged over, with ID a.id comma names with a.name and return accounts comma nil. So that's your client.go file. So your main.go file is ready, client.go file is ready, repository server service we had already completed. Now I'm going to quickly create this file, which is the app.docker file. Now this is going to look very similar in all cases. Here, in this case, this is the name of the project is gRPC GraphQL Microservice. So I just need to make that change here. Right, so name of the folder and name of the project in my case is different. That's why I'm having to change it everywhere. And all I'm doing is just copying go mod, go sum, and vendor folder if there's any. I don't have it yet, but we'll create one. And the account, and then we're just starting, we're just starting the server and then exposing this on port 8080. Okay, that's how we're doing this right now. So firstly, what I'll do is I'll just go to the root directory of this project, and I'm going to just run go mod tidy just to get all the packages that are not there. Okay. And now what I wanted to do was I wanted to try running this microservice, which is account microservice, and what it's asking me to do is it's asking me to get this PB. It's saying no required module provides this. Now that's a problem because I already have mentioned this module here, and on server.co I've mentioned it here, and it's happening because if you notice carefully, what it's saying is it's asking me to get this till PB and then again the same link till PB, right? And the reason for that is that because when in my account.proto file I gave it this link, so what it ended up doing was it went to the PB folder and created the entire link there, github.com/akhil/sharma// and then it created these files inside that. And I don't want that, that's because it's creating a problem now. So what I'm going to do is I'm going to go ahead and delete this folder. And I'm going to regenerate it. And to be able to do that, I'll have to just say /, that's it. Because I wanted to create the PB folder for me when it, just here. And not create like a PB folder inside that PB folder and then, with that link. So that's why I'll just give it this link and let's see what happens. Now I'm going to recreate that. So I'm just going to say, I'm just going to put that command. Just a second, let me try and find it. Yeah, this command finally. Sorry. This one. So so it's saying no such file or directory dot PB. Why is that? So should I create a PB folder? Not sure. Okay, created a PB folder. Yeah, so now the PB folder I had created, it'll place all the files there. So in my PB folder itself, all the files have been placed. All right, and this is what we wanted. And now when I try to go run, now it shouldn't ask me to get that, or is it asking me to get that again? This is on client.go line 6, okay. Client.go line 6. Oh, yeah, so this, I don't want to have this. Let's remove this. Should be just /pb. Okay, so this is not a main package, so we will go inside cmd and cd account and then go run main.go. So it's saying no required module provides this, blah 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 blah. So we'll just say go get, no problem, I can do that. So it's added that, and now when we try and run main.go, we'll get all of these issues and all of these errors, and we can just quickly fix them. So here I can see the issue, which is un_int. It should be just uint, and it's saying too many errors in client.go file. That's completely all right, no problem, we'll fix it. But this looks like a low-hanging fruit, the service.go file. So in the service.go file, I'll just search for un int, and I've done that mistake twice, so it should be uint, and here also. Okay, so I've fixed that at least. And now once I run it again, too many errors. It's saying on repository.go, in the repository.go file, undefined row on line 51. So let me find that repository.go, line 51, row.scan. Okay. Row.scan. Yeah, so it's not working because I have not equated this to row in the first place. At least this error should go away now. Yeah, so that particular error went away. Now I'm getting this error related to PB, undefined PB. So let's try to figure out why that's happening. So it's happening both in the client file and in the server file. It's saying undefined PB, even though I have referred to PB in client.go and server.go file. Okay, that means there could be one issue, could be only one issue, which is this should have been package PB, and even this, right? So I'll just save both of these files, and now if I try to run it, yeah, at least we're not getting that same issue, right? We are getting different issues now. Invalid operation cannot indirect, blah 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 blah. Okay, so now let's solve these issues one by one. Now the first issue is it says on client.go file line 60, and something to do with get account request. Okay, so if I go to client.go file line 60, yeah. So it should, firstly it should be get accounts request because we're calling from the get accounts function, and this would be ampersand. So now I'm hoping this, at least this issue will go away. Yeah, that particular issue went away. Now on line 61, it's saying unknown field skip instruct little of type get accounts request. So if I go back to my code, this is correct because it should have been capital S, and then now I'm gonna run it again. At least that issue has gone away. So that's how I keep running it. It's not a problem to keep running the code again and again to see at least that if that one particular issue has gone away, you know. Then you have the server.go file line 24. Let's see what this means. So if I just run it again, yeah, so I'm getting this issue which is cannot use gRPC server blah 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 blah. What it's saying is that it must embed unimplemented account services server. This is what we need to add in our server struct, gRPC server struct. So what I'll do now is, because of the new version of gRPC, this is a requirement. So I'll go ahead and I will update that here, and if I run it again, it's saying cannot use S as this as literal. That's because I'll have to update this code here as well. So let's update this also. Instead of this, it should be this. And here we are just for this new field that we have added, we are just adding this as well, and then everything else is the same. Because if you notice here, this method that has changed, the method register account services server has changed, and it has, oh, it's in the other file, it's in the gRPC file, and it now requires 2 fields instead of 1 field, right? So we're just refactoring our code according to that. And now when I run it, now those issues have gone away. And now on line 58, so if I go to line 58, it's saying there's not enough fields to call this. So let's think about how to fix this issue. And if we go to line 58, I see that I'm using ID, but here it's get all accounts. So I should not be sending ID here. I should be sending skip and take, which is for pagination, because I'm getting all of the accounts. And now when I run it, I get this issue, line 33 main.go, which is account.new service. And this new service is supposed to come from service and this function new service. And I just realized the issue, which is this is capital N, and that should also be capital N. So go here and I'll make this capital N. And now when I go ahead and run it, yeah, so everything works. It's just that for the Postgres, password authentication failed because we're not running the Postgres server. Once we run the Postgres server and we connect it, then everything will work perfectly fine. Okay, this is what I wanted. So now our account folder works perfectly fine. Okay, account microservice is working perfectly fine. Now we just have to think about the catalog folder and the order folder. And of course, GraphQL also has some issues. But those should go away when we start including these clients and everything. Those should also go away. So now let's do the same with the catalog microservice and then the order microservice. And we'll do the same process. We'll run each of these microservices just like we did with the account microservice, fixed all the issues, and then we'll go ahead. Okay. So for the catalog microservice, I'm gonna have similarly CMD folder, and CMD folder will have the catalog folder, and that will have the main.go file. Okay, and then similarly in catalog I'll have the PB folder like I had earlier. I'm gonna have the at the catalog level, I'm gonna have the app.docker file. I'm gonna have the there won't be a db.docker file in this microservice because this is, we're using Elasticsearch. And here we'll have similarly catalog.proto, just like we had account.proto. We have all the other files, client.go, server.go, service.go, repository.go, and let's close everything off. Now the app.docker file is going to look very similar to the one that we created in account. It's just instead of account, it'll just be catalog. That's it. And here, the other thing that I'll change is this, which is the name of the project itself. All right. Now I'm gonna start from repository, then go to service, then go to server, and so on. Okay, so that's gonna be my approach. And let's start with defining the repository interface. The repository interface is gonna have these methods. So I have the close method, the put product method, the get product by ID method, the list products method, the list products with IDs, the search products. And instead of Postgres repository, we have something called as the Elastic repository, which is going to call the Elastic client. And we'll start with product document, which is what the product has. It has name, the product has description, product has price. So here these methods, right, the put product method is going to have context, which is going to be context dot context. It's going to have p, which is of type product, and error. And before this I'm going to have a variable error not found is equal to errors dot new entity not found. I plan to use this error in this file. For get products by ID, I plan to have obviously context, then the ID as well, because obviously it's get products by ID, and supposed to return a product, the one for which we are passing the ID. Here we are supposed to be returning a collection of products or an error, and what we're going to send is of course the context and along with skip and take. So skip is uint 64 and take is also uint 64, and list product with IDs. This is also going to return a collection of products, and here you have context, which is equal to context dot context comma IDs, where IDs is a slice of strings. Searching for products, query, which is string, because when you're searching for something, you're going to pass the query. I'm going to pass skip and take for the pagination, and you're going to get back all the products that match that particular search query. Okay, so this is what our repository interface looks like. For the product document, in JSON, this is what name looks like, and it's of type string. Description is also of type string, and this is what description field is going to be like. So it's price. And since we have a struct for Elastic repository, we will have a function that will help us initialize that Elastic repository. So it's going to be new Elastic repository, takes in URL of type string, returns us a repository or an error, and we take the help of the Elastic package to create a new client. And this is what ideally the import statement should look like, and package is catalog. So the new mostly this is the Elastic package that I'm using, go package.in Oliver elastic.v5, that's the one that I'm using, and this is what's giving me access to the new client function. So what we get back is client and elastic dot set URL elastic dot sniff false, and here I'm going to handle this error that we might have from above, return nil comma error, and finally return the Elastic repository with the client. I'm not gonna press Control S now, because once I do that, it'll remove all the packages that I'm not needing, but I need all these packages later on. Then I have the close function, and what's important to remember is that these functions are going to be actually methods, because that's how I've initialized my interface, the repository interface. And then I have the function to put product, and I'm going to copy this part here from here. Then I'm going to have my function for get product by ID. I'm going to put this in front of that. Then I'm going to have my function for listing all the products. Then I'm going to have the function to list products with IDs. And searching through the products. Okay, so I have the skeleton for all these functions, and now my job is to create all these functions. So put product r.client.index index catalog type product .id.p.id body JSON product document. So this, we're using this, the put product method, to create a new product. So that's why we have the index as catalog. What we're creating is a product, that's why the type is product, with the ID. Okay. What we might receive is an error. So here we'll have name p.name, we have description p.description, we have price p.price, and here I'm going to say do.context return error. That's my put product method. Then I have my get product by ID method, and here I'm going to use r.client.get. What I might receive is the response index is catalog, type is product, handle the error here. And then what might happen is when we're getting a product by ID, we might not find it. So if the response is not found, then we're going to say return nil, comma, error not found. And this is the same error that we created here, the error not found. Okay, so that's the one that we're calling here. Let's initialize a product document. This one dot unmarshal dot source comma ampersand p, error is not equal to nil, return nil comma error, and we're going to return product from this method because that's what we have mentioned. We're going to return the product from this method, and we're going to say id is equal to id comma name equal to p, name description p dot description, price p dot price, here will be comma error. And now I have 3 more functions left: list products, list product with IDs, and search products. Okay, so let's work on the list products function. Yeah, the list products function has skip and take, as you've noted already, and it's going to return a collection of products. So what we start with is we use the search method available with Elasticsearch. Use index type and here we'll get the response just like we did earlier as well, and after this the query is elastic dot new match all. So the purpose of the new match all query is to match all terms, find all terms that match the query that we have sent from int skip, and size would be tick, and ctx. Now I'll just push all of this to the right so that here I can handle my errors. If it is not equal to null, log dot println error return nil comma error. All right. And now I'll initialize my products, which is a collection of empty products for now. Hits are all the things, all the values that matched, so they're all present in response. We're going to range over them since we want to send back a collection of products, right? And here we'll initialize that with product document, what each product follows the format that we've defined in product document struct on marshal hit dot source comma ampersand p error equal to nil. All right. So we want to return this products collection, as you know. To be able to return that, we are ranging over each of these, each of the matches we have found, and then we are appending that to the products collection. Each product has these values. One is ID, so we're gonna take the value of each hit. So hit.id, name, and description, and price. From this function, we want to return the list of products or any error if there was any error. Next function is list products with IDs. So here also we are sending the list of products, but for all the IDs that we have sent in the query. So we'll have to match the query. So here we start by initializing items, which are elastic multi get item, initializes that, and for ID range over all the IDs, and we want to append just like we did here to the items multi get item. We will have our index, which is catalog. We have our type, which is product, our ID, which is ID, and after this bracket we will call the client dot multi get method, and this will be equal to the response that we'll receive. We'll add items and we'll say to context. Finally, we'll handle the error that we might receive here. So we'll say log.println error, and we'll return nil, error if there's an error. And now we have to, since we have to return the list of products, let's do that. Let's return the list of products. So I hope you're understanding what's happening here is that first we initialized items, which is type of elastic multi get item. And since we have received multiple IDs, right? We have received multiple IDs for which we want to match all the items for those IDs in our database, and we'll return all those items, which will be products that we'll create, that collection that we'll create, which will be in the format of products, right? So we want to range over all the IDs, and we want to iterate over each of these IDs, and we want to find those items, and those items will be available to us in this items collection, which is of type elastic multi get item, right? So that's what we have appended here. And now we want to range over them, unmarshal them, convert them into how a product would look like based on the product that we have defined, you know, what a product looks like. So let's do that. So here I want to return a collection of products. So that's why this will be a collection of products. Sorry. Product document. Unmarshal dot source, $P. And each product has an ID, has a name, has a description, has a price, okay, and finally return the products. So essentially we're just returning the list of products for which we have matched the IDs in our Elasticsearch database. And here all we did was we unmarshaled all each of the items from the items, appended items that all these items that we found with the matching IDs from our Elasticsearch. So everything now is there in the products collection, and we're running that. All right, and now it's all about searching the products. So let's search the product. And here we have the client dot search, and we'll get back response or an error. Same index is catalog, and type is product, query is elastic dot new multi match query. So new multi-match query is a Elastic method which takes in query, it takes in name, it takes in description. So using these fields we can search for items in our Elasticsearch database. Along with our skip and take also. And inside our response that we've received here, by calling the client search method, we'll have all the hits, right? Basically all the values that matched. So let's access those. So P is of type product document and it's empty. On Marshall hit dot source comma ampersand P, and because we have to return all the products that matched, because we're returning all list or a slice of products, let's append to products product where ID will be equal to hit dot ID, name and description, price is p dot price. All right, and finally we're going to return products comma error. So that's our repository.go file, and that's like the lowest layer, right? So we start with repository, then we do service, server, and client, and also the main.go files. There's quite a lot of work left in this microservice itself. It's quite a lot of work left. Let's keep going. Let's open up our service, and here we know that from service we are supposed to have equivalent functions that we created in repository. Supposed to call from the functions in service.go you have to call the functions in repository.go. So we're going to have an import statement here, of course. Going to create a service interface, and the service interface is going to have these 5 methods. Okay. Here there will be post product, get product, get products, just plural, get products by IDs, and search products. These are the few questions we'll have. Now this we have a product document, name, description, price, but we have been referring to product up until now, right? It's product, and we didn't have a struct for that, and I didn't find it necessary to create it at that time because it's going to look the same as product document. It's going to look very similar, just there'll be one more thing which is ID. So I'll just create it anyway now. Type product struct, not much difference. There's name, there's description, and there is price, and only one thing changes, which is ID, which is string, name is also string, description is also string, and price is also string. JSON ID, name, description, and price. So here in the post product we have context dot context comma name comma description, which is string comma price, which is float. 64 returns the product that was created, so just one product. Get product also is going to return just one product, whereas get products is going to return a slice or a collection of products. Get products by ID is going to return again a slice of products, and search products also is going to return a slice of products, and all of these might also return an error. Okay, so here get product, you are going to have, of course, the context in each of these. So I'm just going to copy and paste the context in each of these, and here we'll also have the ID. Here we'll also have skip, and here I'm going to have IDs, collection of strings, and for search you always have the query with which we'll search, this skip uint 64 and take uint 64. All right, and then we define our catalog service, which is the service which is repository of type repository, and a function that initializes this new service. And by initializing we mean it returns a service, so say return ampersand catalog service R, and then we have all these functions, so post product and get product, get products, list products, get products by ID. Sorry, I meant get products and get products by ID, because list products is a function which is here, right? And we're supposed to call the list products function from here. Keeping different name helps us have at least some difference between them, so that we're able to discern which function is from service, which function is from repository. So post product, we know what it takes and what it returns. So I'm gonna just get that here, and this is a method for catalog service. So I'm gonna copy and paste this in all of the functions. Okay, and I'm going to then copy and paste their respective parameters and what they return from each function. Okay, and now we have to work on these functions. Okay, so we're supposed to return back a product, a particular product that we are creating. So here we're receiving the name, description, and price in this function as parameters. So let's get the name, description, price, and ID. For ID, I'm gonna use the KSUID package from segment.io, and I'm gonna use that here, KSUID. Now I'm switching off my camera for some time because I have this convertible desk, so I'm going to be standing up and working because I've been sitting for a long time. So I'll just shut this off for now and keep recording, keep building this. So let me just convert my table into a standing desk. Okay, and now I can continue. So KSUID dot new dot string. And we're going to call the repository function, which is put product ctx / p, error is not equal to nil, return nil / error, and return p, nil. All right, and then we have our get product function. This is just going to call the get product by ID function, and I'm just going to pass context and ID. Let me just get a sip of water. All right, now the get products method, since we have this pagination values, so let's use those. Sorry, take is more than 100, skip is 0, and take is 0, take equal to 100, run s dot repository dot list products context skip take, and then we have get products by IDs, which is return s dot repository dot list products with IDs, context comma IDs, and search products take is greater than 100, skip is equal to 0, return s dot repository search products ctx dot query comma skip comma take. So that's our service.go file. One thing that looks off to me is that there is no okay, first obviously this belongs to package catalog, and the thing that looks off to me is that there's no context package. There needs to be one, because obviously you call in context here, and repository is part of package catalog as well, and this does seem to have all the packages required. Yeah, okay. Now I would like to work on my server.go file. So my server.go file is obviously of package catalog. It's going to have some import statements as well, and just like my server in account, my server here also is going to do with the gRPC server. But if you remember, we made some changes to our server here, right, which is this one. So I'm going to exactly copy that instead here, and my listen gRPC function is also going to be the same, so I'm going to copy that as well. And there won't be any changes, it will be exactly the same. And now I have to just work on my functions, like the post product function. And after this file, as you know, I have to work on the client file, and then the main.go file, and then I will move on to the orders microservice. Okay. Now my post product is a method of type gRPC server. Similarly, all of these other functions are also the same, and I'll just also write func here. And for post product, you're going to accept some parameters. Context is obviously one of those. And if you remember, just like we did in our account, we had pb.postProductRequest. And all of these are not defined, and that's why we need to first define all of that in the catalog.proto file. So let's do that quickly. Syntax is equal to proto3 belonging to package pb. The first is my message product. It has an ID, it has name, it has description, and it has price. And because it's going to be a serialized object, I'm going to have to give them numbers. Alright, so that's my message product. Then I have various other messages like product request and post product response, and get product request and get product response, and then get products request, and which is the multiple products, get products request and get products response. And in the post product request, we have the string name is equal to 1, string description equal to 2, and string price equal to 3. Post product response is just returning the product, so it's going to be product is equal to 1. And get product request string ID equal to 1. Get product response is just the product. Okay. And then get products, the multiple get products request UN64 skip is equal to 1, UN64 take is equal to repeated string ID is equal to 3, and string query equals to 4. Now the next is the message get products response. Products, getting back products, okay. And finally defining the service, which is the catalog service. Post product, and we have RPC get product, and we have RPC get products plural. And post product takes in post product request and returns post product response. Get product takes in get product request, returns get product response, and get products takes in get products request, returns get products response. All right, so that's our catalog.proto file, and it's ready. Now that we have these functions now and all these details, now it's much easier to focus on server.go. So in your server.go, you have post product request here, and you're getting back post product response. Or an error. And here what you're doing is calling the post product function from service, and if error is not equal to null, log.print ln error, return nil comma error. And this has to return a post product response, so let's return that. pv dot post product response product ampersand pv dot product. This has an id which is equal to p dot id, has a name equal to p dot name, has a description equal to p dot description, has a price equal to p dot price, and comma nil. Now it's time to work on the get product function. So get product takes in context R, which is of type pb dot get product request, pv dot get product response comma error. And get products also accepts products request, plural, and pv dot get products response comma error. Okay, here so all you're doing is calling the get product function from the service along with the CT context and ID. And because we're supposed to return the get product response, we're formulating that out here. The get product response has product, and the product has these values, which is ID and has name, has description, and has price, and then we have our get products. Get products, we're going to have multiple products, so we're going to do the same thing where we have our response, which is a collection of different products, and an error, and here we'll handle our query. So if in the request, which is R is the request might have a query. So if the query is not equal to empty, s.service.search products context comma r dot query comma r dot skip tick, else if length of our IDs not equal to 0, then So to get the products, we are going to be passing some IDs, and if the IDs are not equal to 0, then what we're going to do is we're going to call service.get products by IDs method, which we have defined in service, where we take multiple IDs and we return all those IDs. And here we'll have an else. Context r.skip take. Error is not equal to nil. Log.println error, return nil comma error, and then you have pv.product collection of products, and that's going to be equal to products that we're supposed to return from this function. And for this we'll have to range over our response that we've received from either the getProducts function or the getProductsByIDs function or the searchProducts function. So at service level we have 3 different functions. They're all doing the same thing. They're returning a collection of products. And at the server level we have only one function, which is getProducts, and it can call these 3 different functions based on the kind of values we've received. Either it had a query or no queries and no skip and take, or just had skip and take and no query. So ranging over the response, and each of the products will be available to us in P. P is each individual product, and products is the collection of products, and this is where we're going to append will have round brackets. And here you have products, pv.product that has an ID, p.id has a name, has a description, has a price, return &pv. Now I could do this, like I could speed up the video, or I could edit out many of the parts. I could do all of that, but the thing is, I want you to get a realistic view of how much time it takes to actually build something, and it takes hours, So, and you're supposed to build along with me. After the project is there on GitHub, you'll have access to it for sure. But the project doesn't really belong to you, in the sense you won't be able to build it, or you won't be able to edit it, or you won't be able to use it in your future projects if you haven't built along with me. So you might think that once you have access to the code, you can just copy it, fork it, start making changes to it, but that'll be like much slower. So if you just start making changes to it directly, it'll be very, very slow. Whereas if you built it along with me from scratch, you know exactly what's wrong, exactly where to put the fix, and you completely own it. Own in the sense like you have muscle memory around the project, you have complete memory on how we built it together and overall problems we faced. So once you have that, once you have been through that journey, which is like about a few hours journey, it's just a few hours of investment, but then you have this project for life, right? You have this structure or methodology or project structure, architecture for life, where you can use this project in future projects, use this code in future projects, even if you have to build your own product in the future, or you're building for another company, or you're changing the microservices. So now this is like an e-commerce, it has catalog, products, and orders, where catalogs, accounts, and orders, but it could have something else. It could be a CRM, it could be a project management tool, right? The concept would always be the same. So no matter what you're building, you can use this code in other projects. So that's what I'm trying to tell you, that if you build this along, if you've reached this far, you're probably building it along with me. If you build it along with me, you are easily 1% of the total population of developers. And you will see that this video will get a lot of views, like let's say maybe like 2,000, 3,000 views it'll get. And there will probably just be 100 people who will build it from the beginning to the end. And those 100 people will have something called as delayed gratification, in the sense they didn't just watch the first few minutes and then they took the code and then they just didn't see this through. Those people have delayed gratification in the sense that they stayed with the video, they built the project from scratch, they fixed issues, all of that stuff, and now they can use this project in their future projects, and they can use this code, they understand this, they can make changes to it, and they'll have like a solid career, in Golang. If they ever wanted to be a Golang developer, they'll have a solid career. So we have done service, server, we've done catalog, we've done, we just want to do the client.go file and the main.go file now. Okay, so these two files are left, and then we'll do the whole PB files generation from this, and then we'll just fix a few errors in catalog, and then we're done with catalog. So for the client.go file, this is of package catalog. I'm going to import a few packages here, and what we need here is a client. And as you remember, this is the same client that we have in our graph.co file, the clients that we're going to require. So it's good to have this kind of connection in your mind, that what you're building here is actually getting used in another file, and you know where exactly it's going to get used. And the service is pb.catalog service client. Now that we have a client, we need a function to be able to initialize this client, and it takes in a URL and it returns a client, or it can return an error as well. And all we're doing here is using the gRPC package to dial on the particular URL with grpc.insecure connection. Error is not equal to nil. We'll handle the error also here. And finally, pb.new catalog service client, passing the connection and returning finally the client with the connection at C, nil for the error. If everything goes well, no need to pass the error. And then we have our close function to close the connection. And then I need three functions: get post product, get product, and get products. Three different functions is what I need here at the client level. So first is the post product function, which takes in context.context, name, description are both string, then we have price, which is float 64, and it's supposed to return a particular product, the product that we just created in the database. That's the one it's supposed to return. And then I have my function get product, and then I have my function get products plural. Get product takes in context and ID, returns a particular product for which the ID was passed, or an error if something was wrong. And this also takes in context dot context ID string, or an error, can return an error also. And all we're doing here is calling the service level functions. So post product is going to call the c.service.post product function. What we get back here is the response or the error. If there's an error, obviously we'll handle the error just like we always do. And what we want to return from this function, as you can see here, is a product. So we want to return a singular product which we just created. That's the one we want to return from here. And if everything went well, we want to return nil for the error. So here in the post product, we are having context, having pv.post product request, and the post product request has a name which is equal to the name that we just received in this function as a parameter, as you can see. Then you have the description, and then you have the price. Awesome. For returning product, we have these values which match the product struct that we had defined. Description, price. So id has r dot product dot id, r dot product dot name, r dot product dot description, and r dot product dot price. All right. And for importing, if I just say Control S, it's going to import context. And then I'm going to work on my get product function. So my get product function has c.service.get product cdx comma pv.get product request, and then you have the id, if error is not equal to nil, return nil comma error. And finally, the product that we're going to get with the help of the id that has been passed, we want to return that particular product. So as you know, product has id, name, price, description. So I'm just gonna copy this because the values are the same. Then you have the get products plural, and this doesn't take just the id, it takes in IDs, right? It takes in the query, and it returns a collection of products. And before the ID, it takes in skip and take, both of which are uint64, uint64. Get products. So I am essentially going to call the get products function from service, and we will get back a response which is there in R, and we can get back also a error. So if there was no error, then if there is an error, which is error is not equal to nil, and we'll return nil for the value, and error, the value of error. For this function, it takes in context, it takes in pv.get products request, multiple. And let me see if I had, yeah, so here we had get product request, here it's get products request. And the get products requests has these fields: skip, IDs, take, and query. Query is equal to query, take is equal to take, skip is equal to skip, and IDs is equal to IDs. Okay. Yeah, and we have handled the error also. Let me get a sip of water. Now you know that we're supposed to return a collection of products, right? To be able to return a collection of products, we're going to create an empty collection of products. I'm going to range over all the products one by one and append them to the product collection that we're creating. So products is what we'll append everything to, and each product is what we're going to construct here, because each product requires ID, name, description, and price. We have p dot ID, p dot name, p dot description, p dot price, and return products, comma nil. So that's our client.go file. Okay, so we have all the files ready. Now we want to work on the main.go file. And once we have the main.go file ready, one thing seems off, obviously, with the client.go file is that I obviously need gRPC, right? So why didn't it get gRPC for me? This is one big problem that I have with the extensions. They work until they don't, and they get you in trouble. Also, if you've seen this, the other plugin that I have is fluctuating a lot. Sometimes it shows me those errors on the left in those files in red, and sometimes it doesn't. It keeps fluctuating. So anyways, I'm going to get my gRPC package. And then I'm also going to get my package name from here, because I need access to /pb. That's what I've been calling all this while, pb. So it didn't even attempt to get this pb package for me. Weird. And I have my catalog proto ready, and only I think I'll just go over everything again quickly. Everything is ready, only the main.go file is left. And in the account, I didn't work on the up.sql file. There isn't much anyways. It just creates a accounts table if it doesn't exist, which has name and ID. That's it. And I didn't also work on my db.docker file, which is just a simple Docker file for Postgres. That's it. So close both of these. Actually, this if you see me copy and paste this like db.docker file and you get worried, please don't worry. There's nothing happening. There's just 3 lines. There's 3 lines, which is, you know, this is the name of the image. This is just the command that's running, Postgres command, and this is just copying the SQL, up.sql. That's it. Up.sql is this. Okay, so if you know basics of Docker, I don't think this should be at all a problem. All right, so time, I'll just close this off. Time for main.go file. Now the main.go file is package main. Firstly, it's going to import a few things, of course, and it's going to have config. Now when I just saw that problem with the import statement, now I just want to go over all the files quickly and see if everything has been imported properly or not. So this looks all right. Server.go, server.go, there's a problem here. I need gRPC and I need reflection here, both of those things. So I'm going to get my gRPC from here, and I'm going to get /reflection here, and I also need catalog/pb. So I'm going to get it from here. And here also there should be a catalog, because I don't want to end up installing the account pb. I want the catalog pb. So I want that in my server.go file. Okay, so now this looks all right. Now let me check for service. Yes, for service also everything is fine. Okay, yeah. So you gotta keep checking these things, you know, because like I said, the plugins in my case at least, they don't work really well. Struct, then you have the database URL string. Now if I was dependent on those plugins, I would already be in trouble, right? But I'm not dependent on any plugin. So you have type config struct, especially I'm not dependent on GitHub Copilot, because I don't think it does what it says it does. It doesn't give me code that compiles, at least. And even ChatGPT, I don't use it to write code from scratch. Whenever I have an issue, that's when you can go to ChatGPT to fix it, but you can't ask it to do things for you from scratch. At least it doesn't work, at least now, because I use the GPT-4 model. I've used O1 as well. I've used all of those models, and I don't think they're really good to generate things from scratch yet. It's not going to compile, and you won't even, because you have not written the code yourself, you won't even understand where to make the fixes, and that's a big problem, right? So here, just like okay, so sorry, I got distracted. In my catalog main.go file, you know, you can refer to the main.go from account, but there will be differences, but you can refer to it. There will be some similarities, some differences. So I think we should not refer to it too much. Let's make it from scratch, no problem. Where config env config dot process comma ampersand config, if error is not equal to nil, log dot fatal error. Okay. Retry dot forever sleep 2 seconds. Sorry, 2 seconds. And here we have catalog.new elastic repository, the function that we have created already. It takes in the database URL, and you get back a response which will be in R, or there could be an error also. If error is not equal to nil, log dot println error return, and you're gonna defer r dot close, listening on port 8080, fatal catalog dot listen gRPC s comma 8080. So that's our main.go file, and now it's time to create our protobuf files. And since we've done all the work for the account microservice, I don't think we will have to do a lot of work here. Only thing is I will have to add we added here the option go package here, so I will go and add that here as well. And now I think I can go ahead and run the command finally. So let's go to the folder catalog and cmd and cmd catalog again. Oh no, sorry. Yeah, at the catalog level is where the catalog.proto file is there. So here is where we will run this. So it's saying no such file or directory, account.proto. Sorry, it's catalog.proto. So I'm going to say catalog. And it generated, luckily it generated everything that we wanted, but we'll have to say pb here and pb here as well. And here in the readme file I'll go and update this because this has changed now. So now catalog server.go file, everything looks all right. Now we can go to cmd and catalog and try running this. Go run main.go. So it's saying cannot find module providing this package, and cannot find module providing this. I can add, I think. So I figured out the first one. There is no catalog in our line, in our link or in our path. So I've added that, and this package, we'll have to get this package. So go get this package. So let's get that. Now let's try running, and now we'll get some errors. So one thing I can do is I can just say go mod vendor, and now if I go run main.go, now I'm starting to get the errors that we have. So we have unexpected error at end of statement, repository.go 68.5, repository.go line 68. Yep. So we have to have if. So now we are getting the real list of errors, which is quite a lot. And let's go through them one by one. So we have server.go line 15. So was it saying about it? Saying undefined pb.unimplement. Okay, unimplement account server. Why is that? And to fix this issue, what I'm going to do is I'm going to delete these files, delete the pb folder itself and regenerate it. I'm going to create the pb folder, and I'm going to regenerate, because I did go mod vendor. So now I will be using the latest versions of gRPC instead of the old versions. And now if I go again, hopefully this issue should be resolved, because from what I know, this thing is in the latest gRPC version, not the old ones. So I'm going to go into cmd cd catalog and go run main.go. Okay, so now I'm getting these issues, which is undefined pb. Client.go, it's undefined pb. Yeah, that's because we had to change this to pb and this also to pb. Oh no, but we're getting that issue again, unimplemented account service error. Oh, because it should be catalog service error, right? Should be catalog. Okay. Now that one has gone, and we have more issues now. So client.go line 34. Client.go line 34 saying it cannot use price. Okay. And why is that? Everything seems fine to me. Why is this a problem? Cannot variable of type float 64 as string value. Okay. In string, so post product request, have I defined it incorrectly? Post product request. Yep. Should have been double. But I don't think this will fix it. Maybe I'll have to regenerate the proto file, or yeah, I'll have to regenerate the proto file. So let me fix all of these issues that I see. Line 45, client.go, line 45. Is it? Yeah, that's related to the same thing. So I'll have to regenerate it, of course, because I can see that issue again and again and again. So what I'm going to do is I'm going to go through the catalog.file, catalog.proto file properly. So id is string double, and string double product, string product, and then event repeated string product is products. Yeah, everything else is fine. So what I'm going to do now is I am going to come here, delete the pb folder, just the pb folder. I'm going to delete that, and I'm gonna create the pb folder again and regenerate everything in the pb folder, and again I'll have to update pb here, and and then go inside cmd catalog and check. Why is this still an issue? I have no idea. Didn't I just fix it? I did just fix it, and I also recreated the catalog file. Then why is it an issue still? Alright, so I was still struggling with this issue, which is cannot use r.product price, this file, client.go file line 45. And I was thinking it's because of the catalog proto, but that's not the case. It's because of this one here. So this needs to be float 64. And now this issue should go away. Yeah. Now let's see the second question. Second one is cannot use pb.getProductRequest. Okay. line, is it this line or line 52? Yeah, this is the line. And the get product method, right? Why would that be an issue? Everything looks okay. Get product request. And the solution of this bug is not here, because here everything is fine. It's actually here in the catalog.proto file. Here, if you see, instead of get product request, by mistake I've written get product request, and that's what's causing the whole issue. Now client.go line 67, this is a easy fix. Just search if anywhere else I've done u in int, because I seem to be making a lot of mistake here. Okay, and repository.go cannot convert client. Type elastic repository, repository.go line 43, elastic repository. That only makes sense because this is supposed to be curly braces. Now let me run this again just to see. Why did that issue not go away? Get product request. Oh, because I'll have to regenerate the proto file. That sucks. That really sucks. Okay, no problem. I will regenerate these two files. So here I'm gonna run that in the catalog folder. This will be catalog.proto. I think it's because I'm using WSL and I've restarted it recently, so maybe it's rewritten all the path variables. So at least I'm going to go ahead and check if these extensions exist. What is this? No, it's saying it's not being able to find these extensions. That is just sad. So I'll have to reinstall all of that again. Not a problem. I'll do all of that and come back. Okay, so as you can see, I had to do everything from scratch. I had to get even Proto C. I had to install the plugins. I had to set up my path. And now I have again created the proto files. So now I'm going to try running this again, and now it's giving me that same undefined PB error. Okay, so at least that error has gone away. And now we have many more issues, many more errors. So it's saying cannot use p.price as string, blah, 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 blah. Okay. This is repository.go, line 57. Product document. So the product document, also the price here in product document as well is string. I just wanted to see where else this has happened. Okay, so now hopefully some of these issues should go away. Now repository.go line 88. undefined. Client is undefined because C should be capital. 126 also, and here C should be small. So first I'll just run this and see if the errors that I've just fixed have gone away or not. They have. So here on line 88, client.search undefined, client.multiget undefined. Okay, let me see. Oh no, it's my mistake. It's going to be small, but it's going to be r.client. And similarly on line 126, it's going to be r.client again. Okay, so those issues have gone away. Now server.go. So repository.go is fine. Now client.go is fine. And now you can see all the issues are in server.go file. Line 25 is what we'll start with. So it's saying register accounts service server. Yeah, of course, because this will be catalog server. And it's saying server.go unknown field. Okay. Yeah, we'll have to make some changes here. So it says account service in both places, and obviously it can't be account service, it has to be catalog service. And what happens now is that we have these two issues left, which are line 48. It's saying this is undefined. That makes sense because this should be get product with a capital G. And then it says line 67 s.service undefined. Line 67 s.service undefined. Makes sense. Now we only have main.go file. So it's saying line 16 in main.go file. r.catalog.repository unexpected. What does that mean? Yeah, sorry, there won't be any dot here. The variable is r and it's catalog.repository. Okay. So hopefully when I start it now, it should ask me for yeah, so when I fix it, it should ask me for Elasticsearch. Should ask me for Elasticsearch connection to Elasticsearch, and it should not be able to connect to Elasticsearch because we're not running Elasticsearch, and only then we can be sure that all issues are gone away in this particular microservice. Okay, so line 16, line 22, line 16 env-config, essentially saying that it's not able to understand what is env-config and retry, env-config and retry, and that's only because we don't have those two packages. This is again where the plugin failed me. Okay, undefined forever sleep. It should be forever sleep. Okay, makes sense. Isn't it forever sleep? Yeah, it is forever sleep, but with a capital S. Now it should talk about Elasticsearch, hopefully. Cannot connect to Elasticsearch. Something like that is what I'm expecting. Yes, no Elasticsearch not available. So that's awesome. Our account microservice works perfectly fine, and our catalog microservice works perfectly fine. I will work on the order microservice now, and then I will fix the GraphQL, and then we'll just start Docker containers and with all the respective databases like Postgres and Elasticsearch, and then everything should be fine. Everything should work properly fine. But like I said, we'll have to fix all the issues in the order microservice and the GraphQL microservice. So what we're going to do is we're going to build the orders microservice, and we'll be following the exact same approach. We'll work on repository, then we'll work on all the service, server, and all of that stuff. The folders I need is CMD. Inside CMD again I need order, and at the order level I need the PB folder, of course. I need the app.docker file. It's not a folder, sorry. App.docker file, and I need now the client.go file, sorry. And I need the repository.go file. I need the server.go file. I need the service.go file. And I need inside order, I need the main.go file. Then here I also need the db.docker file. And I need the up.sql file. Okay, so I'll close everything from here first. The up.sql file will have two tables. I'm working on the up.sql file before repository because obviously that makes sense, because repository file is supposed to connect with and talk to the database, right? And supposed to have documents, database related commands. So I'm creating a table called orders, and I'm also creating a table called ordered products. So the order has ID created at account ID, because every order is associated with an account ID and the total price of the order. And ordered products has an order ID, product ID. Like basically all the products that belong to a product, so they all have the product ID, quantity, how many of that particular products have been ordered. So you have quantity as well. So that's your up.sql. Your db.docker file is straightforward, is the same, running the Postgres command, Postgres 10.3 image. And we copy the up.sql file and we initialize it. The app.docker file is going to have everything same. We have go, the run command, work directory, all of that. Now on my other PC, I usually use older versions of Golang, but when we were building this project, we ended up using, by mistake, we ended up using the latest version of Golang 1.22.5. I use the older versions just for stability and just because my microservices, like in production, they all belong to the older versions. I've not been using the newer versions of Go. So what I'm going to do is I'm going to have to upgrade the app.docker file. So I will just copy this. And by the way, this is all of this is through ChatGPT. Like ChatGPT writes Docker files really well. So this is with ChatGPT. And here also, what I'm going to do is I'm going to tell ChatGPT to upgrade this file as well. Now I could just change this line and everything would be fine, but I don't want to take that chance. Maybe there's some other refactoring required. So, you know, it's better to use ChatGPT to generate the file for you. And similarly for the account one also, we'll do that. All right. Now, like I said, I will start working from the repository.go file. And what I'm going to do now is I'm going to create my repository interface, close. Now, if you remember, the order microservice is supposed to interact with the account and product microservice, which I had shown you in the diagram. So I'm going to be slightly careful when creating the order microservice, because there's going to be multiple connections with other microservices, and if I mess it up, the debugging will be slightly more difficult. So only when things get slightly more serious is when I start getting more careful. Otherwise, I'm completely careless while writing Golang and Rust code, like completely careless. I just write any shit, and the compiler helps me. The Golang and Rust compilers are like literally the best in the world, and they will guide you through every single issue. They'll tell you where the issue is, on which line, how to fix it, all of that. So you can be totally dumb and write anything you want and still fix it. The only caveat here, however you know pronounce it, is that when there are multiple microservices involved, that's where things can get a little tricky. So there's the standard put order, which creates a new order. That's why we're passing a new order here, which can return an error, and get orders for a particular account. So an account ID will place multiple orders on this e-commerce store. We're supposed to return all of those orders by accessing his account ID. And you have your Postgres repository, and I'm going to use the SQL package, the database /SQL package. This obviously belongs to package order, and I want to import. If I save, it imports context and database SQL for me. Awesome. Okay. Now, because we have the Postgres repository struct, we obviously need a function to create a new Postgres repository. Got the string. And you open up a new connection. And if while opening the connection there is an error, we'll handle it. So return L, error. Ping the database to check if the connection has been established. If there's an error there, we'll return return the error. If everything went fine, we're going to return the Postgres repository with this DB connection and nil for the error. I want to have a simple, straightforward function to close the database connection, but it's going to be a method for the struct Postgres repository. And then we have our put order, which has context dot context o and order, returns error So I've realized that order, it's not detecting order because obviously we have not created the struct for order, and that's supposed to go in the service.go file. So I'll say package order, and I will create the order struct. So what all does an order have? It has an ID, it has created at, it has total price, it has an account ID with capital A, and it has products. The ID is string, created at is time, total price is float 64, account ID is string, products is ordered product. And I ideally want this to import the time package. It did. The service interface has post order and get orders for account because of these two functions, get orders for account and put order. So here we have similar functions. We're going to call the similar functions in service. Save this. It's not able to detect order. No problem, I'll come back to it later. So we have put order here. Put order is a struct method, and we have a transaction, and here I'll handle the error. If error is not equal to nil, return error, and then a function that I'll call at the end, where I'm checking for error is not equal to nil, and I'm going to roll back the transaction. Commit the transaction, and here I want to place the actual Postgres function, which is insert into orders being the database that we created using the up.sql file, passing ID, created underscore at, account underscore ID, total underscore price, and these are the values I want to place there. $1, $2, $3, $4, and O is which is the order that I'm receiving. It has all the values. So repository, as you know, is at the foundation level. We're getting the order values from the server or the service. And that order will have all these values. All the values are required based on our order struct, which is ID. Then I have my created at, I have my account ID, my total price, if there's an error, we'll just return. Now the only reason I'm using transactions here is because there are multiple things happening, like orders, and which are dependent on account and price, and when the this function closes, we need to, and it's done executing, we need to ensure that the order is either committed or rolled back If there's an error, we roll back. Otherwise, we commit the transaction. That's why I'm using it. And now, now that we have inserted the order, now we have to insert the products. So I will say tx dot prepare context, and this is why using transactions is important. So pq, as in the Postgres package from GitHub, I want to use that, so I'm going to go ahead and place it here. Why, when I'm using it here, why doesn't it let me? I have no idea. Copy in, and here I'm going to have the order products, comma the order ID, comma the product ID, the quantity. And I'm going to capture this in statement variable. And I'm going to range over all the products in the order. So every order you'll buy some products, right? And so you'll have this collection of products in every order. That's what I'm accessing right now. And all of these orders I have to copy in the order products table, which is this other table that we have. So here we have for p ranging over each of these products, and execute context. And we have these fields, the order ID, product ID, and quantity. All right. Handling the error here, return. Exec context, CTX here, and then again we will handle the error. Right, so I hope everything is clear that we are updating the order in the order table and updating all the products in the ordered products table. These are two things that are happening. Return. Now the next is next function that we have is getting orders for account. So I've turned off the camera again because I have to stand up and write this. Can't keep sitting for a long time. So here I'm going to create my get orders for account function, and then my yeah, that's it. That's the only other function we have to create, get orders for account. And this is going to take context dot context comma account ID, which is string, collection of accounts is what you'll get back from here, and errors. Now this is obviously a struct method, so I'll add this here. So we'll pass query context, and we'll pass our context in the query context, and whatever I get back, this will be the rows from my database, and I'll have to obviously process those rows. So I'm going to capture that in the rows variable, and I'm also going to handle this error here itself. Okay, and after this I will close the rows as well. Okay, so here I'm going to have my function, which is select o.id, o.created at o.account id. Just have to be careful here. o.total price from orders. So OP in this case is ordered products and O is the order. So from orders, O join ordered products, OP on o.id equal to OP dot order underscore id, where o.account underscore id equal to $1, comma account id, comma. Order by o.id. Yeah, now it looks okay. Then we need orders equal to order, collection of orders that we're supposed to return from this function. And the last order, which is again an empty order, singular order. And then we have ordered product, which is of type, which is an ordered product and products plural, which is a collection of ordered products. So what we'll do is we'll go back to service, create ordered products. So here we'll get type ordered product, and it's going to have ID, name, description, price, quantity. So last time I made mistakes here in the fields. Just need to make sure I don't do that anymore. Okay, and I'll just also create an order service just like we always do. Which is repository. And then because we have an order service, we'll create a new service function which returns a service, returns an order service to be more specific. And here we'll just have again two functions, because we just have to call two functions from repository. So there will be two functions. One will be post order, and this will be a struct method for order service, and the other function will be get orders for account function. Now post order takes in context and account ID and products, which is ordered product, and returns an error, and get order for account, get orders for account, takes in and returns a collection of orders or error. All right, so now going back to our repository.go, because that's what we were working on. We reached here, and now we have to perform operations on our rows. So we'll say for rows.next, we'll scan the rows and we'll have our order dot id, order dot created at, order dot account id. These are the various fields, and total price of the order, this we'll have to calculate, and ordered product ID and the quantity of the ordered product. Now we'll scan the order, so we'll say if last order dot id is not equal to empty and last order dot id is not equal to id, we have id, we have account id, and this will be equal to last order.id. Just put one more tab just so that everything looks ordered, and then this will be last order dot account id, this will be last order dot created at, this will be last order dot total price, last order dot products. To the orders, we'll append the new order, which is all of these details we created, and products we'll initialize as an empty collection of ordered products. And then we have to just append the products, so we'll say products append to products, ordered product, there's ID and there's quantity. Ordered product ID, third product dot quantity. Last order is equal to order. Okay. Now we'll add the last order. So if last order is not equal to nil, create a new order with all the exact same details along with this. And after this we say if is equal to rows dot and return orders comma nil. So this function get orders for account is taking in the context and account ID, returning a collection of the orders, okay, for that particular account ID, right? So it takes in the account ID. For that particular account ID, whatever orders have been placed in the past, we will return that list of orders. So first we start off by executing a query where we pass in the context we've received in this function. We create this, we run this query which is selecting all of these details, where we're selecting details from order table and from the ordered product tables, joining the data, and we are checking for that account ID where we're passing this account ID where we have received in the function exact for that account ID, and we'll order that by order ID. So those are the details that we want. Now everything that we received, we'll have this in rows, but if there's an error, we will handle that error. Important thing to note here is that, here we are just initializing all the fields that we'll need to work with the rows that we've received. Now rows.next helps us to iterate over all the rows, okay? And it's important to note that all of this is inside this rows.next. So we are using the for loop to go over each rows one by one. And if the order ID is not the same as last order, that means we are processing a new order. That's why we create a new order here. These are all just the fields we are scanning. Yeah, so we're creating a new order here, and we append that new order to the orders collection that we are supposed to send back from this function, and then we create a products collection, and then we append that to the products, also the ordered products that we have as part of that order. If a new order starts, we just create a new order and append it to the orders. That's all that's happening here. And we'll just return an error if there's an error, and then we'll finally return the list of orders that we have found for that account ID from the database. So from an 10,000 feet perspective, all that's happening here is we're just returning all the orders that particular account ID has placed. And now it's time to work on our service, and then our server, and then our client file, and then obviously the main.co. So for the service, we have done most of the part up until now. So the server file is gonna have our gRPC related stuff, but in this case, in this microservice, the gRPC related part is a little different. So let's quickly finish off our service so that we can work on the server as well. So for service, everything is going fine. We just had to complete these two functions, which was the post order function and the get orders for account function. Okay, and here we just have to complete this also. Let me see if this is perfectly fine, or is there something else that's required here. Everything looks good in the repository to me. For service now, we have to complete this. So for post order, takes in all of this and returns all of this. And it returns order, a particular order, the order that we just created, and an error. For get order for account, I'll copy and paste this here. Okay, so now everything looks all right to me. I'm just gonna check the ordered product. Yeah, that also looks fine. We have the order service, the new service, and then these two functions that we can now quickly complete. So we start off with an order. We have defined the struct for the order already. It has an ID created at, it has account ID, it has products. So products is equal to products, account ID is equal to account ID, created at is a timestamp, which is the timestamp for now, whatever the time is right now, and ID is equal to ksuid dot new dot string. And here you have total price equal to 0.0. So we initialized total price as 0, and we'll range over all the products that we've received to calculate the total price. We'll multiply that by the price of each item multiplied by the quantity, the number of items ordered for each product. And then simply calling the put order function from the repository file that we just created. And here we'll check if error is not equal to nil, then we'll just return error. And return order, that particular order that we just created, comma nil for the error. The get orders for account function is straightforward. It's just going to call the get orders for account function from repository and nothing else. And that's it. That's our service.go file. And now we are left with okay, for service.go file I need the context package and ksuid, because I just used context and I just used ksuid. So why didn't it get it for me? I have no idea. So let me get those. Done. Service looks good. Repository seems to be having a lot of errors. We'll fix all of that, of course. And now I want to focus on my server and then on my client.go. But also we haven't really started thinking about the order.proto file yet. That also needs to be created, right? So we have quite a lot of work for us. If you've reached this far in my video, just wanted to tell you about Armor, because I'm the founder at Armor AI, and we use LLM agents for code vulnerability scanning. What that means is that there are these, when you log in, right, when you launch app, and then when you log in, you come to the dashboard, and then you can also go to the AI security tools, where we have all of these multiple types of security tools. And one of that category is the code scanning tools, which is like our primary category. And you can come and scan your code here for security issues. The one you have to use now is the quick use in browser. So I can just come here and I can simply paste my code here. So let's say I created the repository.go file. I'm going to copy and I'm going to paste it here. And I'm going to, so it's saying estimated credits are 6. So 6 credits will be used up when I scan it. So once I start scanning it, it says scan in progress, and it starts off a new AI agent workflow, and it starts off this process. So this takes about 10 minutes or so, and you'll see each of these tasks getting completed one by one, and this percentage also going up. Now the thing is, regular static scanning tools like the ones you already use, right, the ones that are there in the industry, they are not able to find issues as well as something that uses LLM agents. And the reason is because this, if you've seen my LLM agents videos on YouTube, you know that agents are able to create collaborative workflows, as in we are able to create collaborative workflows with agents, and each agent is able to check each other's work, and then the output that you get is like really accurate and really useful. And that's exactly what you get in this code scanning. I mean, the kind of output that you get here is unparalleled. Like you can't get this kind of an output from any other code scanning tools on the planet. And I'll just show you in a minute what it looks like. And what we'll do is we'll come back to it. And I'll just show you some of the other tools, because till the scan is underway, it's 42% done. I'll keep going on. So there's also the same thing for Rust. And each of these tools, right, you can import code directly from GitHub. So you can just connect your GitHub and import code from there. You can also upload your source code directly and start scanning. Whenever you sign up, you get about 100 free credits. I have 5,000 credits because I'm the founder, so I can have as many credits as I want. But you get 100 credits, and if you want more credits, like I would request you to sign up, check it out, because this will really, if you're building something very serious in production and you don't want security issues, and you don't want to worry about sitting and finding security issues on your own or even fixing them, because I'll show you how Armor suggests recommendations to fix those issues also for you. So if you don't want to do all of that manually on your own, take your time, you can just use Armor quickly. So you can import your code from GitHub and scan. You can just upload the code. We are also coming up with the VS Code extension and the GitHub app directly. You can use it in the GitHub app directly. So these two are still, like, even though when you click on it, you can download the scanner VS Code extension, but it doesn't really work well. Like, we haven't worked on it properly. So only the thing that works really well right now is the quick use. This one works really well, so you can check it out. The APIs also work. In case you want to use the API somewhere else in your project, you can try that. If you want more credits, you might be there on my Discord community, right? The Akhil Sharma Discord community. Make sure you drop me a message and I will give you more credits, not a problem. Or you can message me on LinkedIn or Twitter or any other place, no problem. I'll give you credits. Or you can just comment on this video if you want credits. I'll get in touch with you. But yeah, do leave me with your contact details or something so that I can get in touch with you. So it's done now. It's 100% done. So when you view it, firstly you see the agent log. So everything worked fine. If there's an error, you'll see the error somewhere. Which stage the error was. And the code scan output looks like this. So you get the list of security issues. So you get lack of input validation and sanitization. So obviously the code that I've written is not production. Is not built for production, so that's why you'll get a lot of security issues. To remove security issues, it's a long process, but Armor gives me improvements and fixes. It tells me exactly where to make the fixes, and also it's telling me to improve error handling and logging. It's telling me how to use the deferred rollback properly. It's telling me how to validate my SQL statements. It's telling me how to manage data loads. It's telling me to ensure proper handling of repaired statement, and gives me a complete conclusion. So imagine like this kind of report you don't get for just like barely 100 lines of code. You're getting such a long report. And yeah, so we were done till here. Now it's giving me all these code fixes. It's telling me how to handle transactions, how to properly handle data preparation, proper resource cleanup, how to optimize scanning, and how to fix error handling. And so it'll do all of that, and it'll generate the optimized code for me with all of these considerations applied, right? Imagine, so nobody does that for you. So all I have to do now is I just have to copy it, and I just have to paste it here in the repository .go, and that's it. As you can see, most of the issues have gone away, right? So there's only one issue left. So this is what I love about Armor.ai, and this code not only doesn't have any like major bugs now, it doesn't have security issues. That's the main thing, and transaction error handling. So it's giving me explanation of all the issues, fixes that it's applied, and then it's giving me all these vulnerabilities. So it's giving me that this tx.execute context can result in SQL injections. The code does not check for errors, blah 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 blah. The call to this function does not check for errors again, and there is potential SQL injection. This can get orders for account if account ID parameter is not sanitized properly. So it's giving me all of these issues. Try using all the other tools on the market. You won't get this kind of a report. And then just to go beyond, Armor AI also creates test cases for you. So you get all these test cases created. You can just use them directly. It also explains these test cases for you. And then if that wasn't enough, let's say you wanted to go for a proper professional security audit to some company, and they ask you for your documentation. We give you documentation, but something that's prepared for a security auditor, not from a developer's perspective, but from a security auditor's perspective. Each function has been explained properly, and that's all that you get. So this is pretty awesome. And not only that, but you also have, if you're a Solidity developer and you want to audit your Solidity code, this is like the best tool on the market for sure. Try it out. And you get your first audit free. So doesn't matter, even if you have like 100 credits. Actually, auditing tools, they require like 400 or 500 credits. They require a lot more credits. So do message me if you want more credits. I'll give you like 1,000 credits, not a problem. And yeah, I'll give you 1,000 credits. And in exchange of that, you just help me improve the product. Just give me feedback. That's all that's required from you, nothing else. You can also use the Move. If you are a Move developer and you write a lot of Move code, you can check out the Move tool as well. You get your first audit free, so your credits won't be deducted for your first audit. But the first audit is limited to like 500 lines of code. The second audit onwards is not limited. And we're coming up with more tools. So yeah, do check it out. Do let me know. It's armor.ai. You sign up and get 100 credits free. All right. Now let's get back to our code. Now we already know that the server.go file and the client.go file, they both require the protobuf folder, right? We keep accessing, like we keep referring to the pb folder all the time. So this is why I'm going to first create my order.proto file. Then I'm going to create the all the pb files, and then I'm going to work on the server.go file. I hope that makes sense. So let's get started. This is syntax is equal to proto 3 package pb, and then there's this line that I have to copy from here, which is and then I have the message order. So the first is the order product message. Okay, what does it have? It has, now I have to be careful here because you remember we have to keep regenerating our all the protobuf files. If you're not careful, sorry, I'm just drinking a sip of water. So I have string ID, string name, string description. I have double price here. Make sure you don't write string by mistake. uint, don't write unint by mistake, right? All those mistakes that I've been making. Now see, I could have used plugins, right? I could have used plugins, and then that ways what would happen is I wouldn't become more intelligent, or I wouldn't become more experienced. So right now, if you just see what I did was I'm being careful to not write unint. I'm being careful not to make that same string mistake here. That's only because there was no plugin that auto corrected everything for me, and I could, you know, there was no level of abstraction. I couldn't just ignore it. I had to do it myself. So it built muscle memory. It built that pain or muscle memory that, hey, don't make those mistakes again, otherwise you'll have to recompile everything. So this is the benefit of not using plugins, right? Otherwise I would just use Armor AI for everything, but I don't. Like, I only use it for security issues, right? As you saw, when I have to fix security issues and completely refactor the code. So it completely refactored the code, everything that I just wrote for me. And this is from a security standpoint alone, because us developers, we don't want to get involved into security, right? That's a security professional's job. But sometimes when you're building out something important, even though it's a private project and we can't afford like a $10,000 security audit, and we want to do everything on our own, this is where Armor comes in. That's where it saves you. That's why I even built the product, because I realized this problem with all of my developer friends and all of my clients as well. Then you have, oh, by the way, there's also a Discord community for Armor AI. So in case you use the Armor product and you want to be on the Discord community for Armor, give us feedback, stay in touch with you know, everything that we're doing at Armor. please let me know. I'll get you added to the Armor Discord community. And then you have message, or maybe I'll just I'll try and remember to add the Discord community for Armor's link in the description of this video. Then you have order product ID equal to 2. Then you have uint32 quantity. And I would love to know from you guys if you find it extremely useful, you know, and how can I improve it. It'll be amazing. It'll be a lot of help for me. Quantity is equal to 3. So you're using post order request, which has a complete order product message and also product ID and quantity. Then I have my post order response. So for each of these requests, there is a response, as you know. So you have the post order response, which is a message, and get order request, and get order response. Then get orders for account request. And message get orders for see, I started making mistakes already here. Oops. Okay, I've made a lot of mistakes. So let's go with everything one by one. So post order response sends back the order. The get order request has to take in the ID, because you want the ID of the order that you want to request. The response will obviously have order, but the get orders for account request will have the account ID. And this will be equal to string. Get orders for account response. And then we have service ordered service. So we have one RPC which is post order, the other RPC which is get orders for account. This takes in post order request and returns post order response, whereas this one takes in get orders for account request, returns. Yeah, so I need to make sure it says returns, and after this we'll have to check the file once, because once we generated it, it's difficult. Get orders for account response. Okay, now let's check this file properly once more. Message order has message order product, string is ID, string name, string description price, and uint32 quantity. Then you have string ID, bytes. Okay, everything looks all right up until now. Then you have the post order request. Okay, quantity is 3. All right. And then you have string. So the post order request is going to have the account ID, not the product ID. and it's gonna have, see, already I've started making mistakes. Repeated order product and products. Yep, now everything makes sense. So that's your post order request. Then we have our post order response, which is order, get order request, which is string ID, then get order response, which is order, get orders for account request, and get orders for account response, and our two RPCs, the first one being post order, which takes in a post order request, returns a post order response, and get orders for account takes in the get orders for account request, returns get orders for account response. Okay, so that's a proto file. And now it's all about generating the proto file. So cd order, and now I have to find that command. The command was here. Instead of this account, we will replace it with order, and we have our order files, but here we want to replace that with pb, replace that with pb. Okay, this feels all right now. Order profile is done, and now it's all about working on the server, client, and our main.go file. Okay, out of all these, the main.go file is the easiest because it doesn't have much going on. I'll just create that then quickly. So sorry, package main, some import statements will go here. Just drink some water. Database URL, account URL, oops, and catalog URL. Database URL is a string. This is also a string, and the catalog is also a string. So here we have, yeah, so here if you notice, it's dependent on account and catalog URLs. So here we have env config database _URL, env config, we have account service URL, and here we have config catalog service. Oops, URL. Okay. Then I have my func main, creating my configuration variable, which is equal to config struct type, and nconfig dot process. Right, so it got the right package, nice, comma ampersand config. If error is not equal to nil, log dot fatal error, and repository, and then the retry package forever sleep. I remember it's forever sleep. Right, so last time I made this issue where I put a dot here, so I avoided that, and this time I avoided this forever sleep also. It was forever leap that last time. I made a mistake there. This is how you build muscle memory, and it stays. Trust me guys, it stays, because the more you write and the more you do, the more you the better you get, basically. New Postgres repository cfg dot database URL. Error is not equal to null. Log dot print ln r dot close. Alright, so that's our main.go file, and I have a feeling that I've done everything correctly here, because I have like so many battle scars from fixing issues before in my life. So I've tried to be like extremely careful here, and but still, you know, you can't be careful enough. You'll still end up making mistakes, and that's completely all right. I don't think that's like totally avoidable. That's why you have to rely completely on the rely a lot on the compiler. But yeah, I'm just going through it once, checking, because one check now saves time later. And to be honest, it looks really all right. And yeah, so server and client are the only two that are left. Out of these, the client is obviously going to be much simpler and smaller, and the server is going to be a much larger file. But yeah, let's work on that then. So what do we have in the server? We have package, obviously it belongs to package order. We have the gRPC server with the struct containing service, which is of type service with a capital S. We have count client, which is count.client. We have catalog client, catalog.client. Okay. Then we have the function to listen to gRPC, S of type service, passing the account URL, the catalog URL string, the port with an integer, error, account client will have a new client from account. Now, as you know, order is dependent on account and catalog, so that's why we're having to create servers for both of them. And this error, I'm gonna handle this error, and then I have my catalog client so obviously that means I need my catalog and account, and it was able to get those for me, those packages, which is awesome. And here I'm going to return the error. Then I'm going to use the net.listen package to listen on the TCP port and pass in the port. And check for error. So if error is not equal to nil, account client dot close catalog client dot close and return error. Then we create a new gRPC server. And since we already have our protobuf client, we're going to have, if we have protobuf files ready, we can create register order service server, pass in our gRPC server, with s comma account client comma catalog client and reflection dot register, passing in server return serve dot serve lis. Okay, so our account client, we have initialized our catalog client, started the server, and if there's an error, obviously the account client catalog client will be closed. Starting our server and our registering our server with the protobuf register order service server, and this should be small s. Okay, and then we just have two functions, the post order function and the get orders for account function. So first things first, pb dot post order request and returns pb dot post order response comma error. So what does this function have? First, we will get the account. To do that, we need the account client, and the get account function requires context and account ID. Then handling the error getting account. Now I'm keeping my explanation to a minimum because but this is the third microservice we are creating, and by now you know all the steps that we usually take. All the steps that we're usually taking, you already know them. So we initialize a slice of strings empty, which is going to be equal to product IDs, and to get our get products, if you remember the get products function from account, sorry, from products, the get products function from catalog, the get products function, this one, it can call, it takes IDs, right? So that's what we need here. That's why we have product IDs. And I'm gonna call the get products function context 0, 0, product IDs, and we need the catalog.client to be able to call this function. And what you get back is the list of ordered products. And there could be an error, so we'll handle the error. So if error is not equal to nil, we'll say log println error getting products and print out the error. I'm going to return nil, comma, errors.new, products not found. Then we'll create, initialize ordered products, an empty collection of them, make that equal to products, and we'll range over this variable, which is the ordered products that we just got from the getProducts function from the catalog client. Okay, so remember, we're going to call, I'd informed you that from the order microservice, we're calling the clients of the other microservices, right? So we call the client of the account, and then they call the client of the catalog microservice. And here we are going to range over the ordered products, and each of these will be available to us in P. We have our ordered product here. We have ID, quantity, we have price, we have name, we have description, and ID equal to p dot ID, quantity equal to 0, price p dot price, name equal to p dot name, description equal to p dot description. Range over these products. Break if product dot quantity is not equal to 0, products equal to append products comma product. Okay, so now finally what we created this function for, which is because when you're creating an order, you want to post an order. When you want to create an order, you first want to get all the products that have been ordered in that order, right? So the an order requires an account, because orders are associated with accounts. An order needs all the products and their quantity, right? So that's why we did all of this, like checking the quantity, appending that products to the product, all of that. This is what we did here. Now it's time to actually create the order. So that's post order. You have context comma r dot account ID comma products. So s dot service dot post order. And if there's no error, we will handle, sorry, if there's an error, we'll handle it. We'll say error posting order, return nil comma errors.new could not post order. And then, like we have always done, we will use protobuf and create an order for our protobufs. We'll call it order proto. It has an ID, order.id. It has an account ID, which is equal to order.account ID. It has a total price, which is equal to order.total price. It has products equal to a collection of pb.order underscore order product. And to get order proto dot created at, which is the timestamp, let's get it from the order itself. Created at, okay. So this means I have made a typo somewhere. Oh, created at. Have I made this mistake somewhere else also? No. Okay, awesome. So created at dot Marshall binary, and now we'll range over all the products. So we'll range over and order, add them all to order proto dot products. Let's append them to order proto dot products. Now what we're doing here is an order has this, right, order product, which has ID, name, description, price, quantity. So this is what we're working on out here. So we are appending all of the products here. Okay, so we're okay, so firstly this will have and then dot order underscore order product. And finally we'll return the post order response, which will have the order, which will be equal to order proto and nil. So this is our post order function, and now we will also create our get orders for account function, which will also have quite a lot of details, and then we have to work on our client.co file. And only then the project will be over, after obviously we fix all the issues here in GraphQL and we finish the Docker Compose file. That's when the project will be over, so it'll take some more time, not a problem. So in server.go we are at post order, and now we want to get orders for account. All right, now we take in context here, r, which is pb dot get orders for account request. And as you know, this is a method for the gRPC server, so I'm going to add that here. All right, and for account response, comma error. So first things first, we'll get orders for account s.service. We're going to call the service, this function in the service. We have to pass the context and account ID. And whatever we get back is in the account orders. Then we will handle the error. And then we get all the ordered products. So we have a map. Product ID map is equal to map string, and then we'll range over all the received account orders. So range over these. We have our product IDs, which is a slice of strings, and we're going to range over the product ID map. And append that to product IDs, each ID after we've ranged over them. Now for the IDs that we have, we will get those particular products. It's just like we had called this function before. And that's available to us in the products variable. And we'll check for error, print ln error getting account products, comma error, comma error. Let's see a collection of orders and range over account orders. Ordered product is equal to pb dot order, and here we have the account ID, we have the ID, we have the total price, and we have the products. op dot created at o dot created at dot Marshall binary. Now we'll decorate all the orders with the products, so we'll range over all the products. Okay, so now I'll explain everything to you. I entered into like a meditative frame of mind. I'm sure this happens to you also when you're building something and you forget that you have to explain. I do face this challenge sometimes because I enter into that like very relaxed zone where I've just focused completely onto just first fixing and completing it, and then now I can explain it because it's done. Otherwise it is getting a little distracting to explain while writing the code. So if I want to get orders for a particular account, I can pass that account ID to my service. There's this function in my service, in the order service, called get orders for account. So I'm going to get all the orders, but I want to extract all those products also, right? So all the products that I receive as part of that order, the account order, because I'm ranging over account orders, and each order will be in O, and each order has the list of ordered products along with that order. I'm going to get all of their IDs in something called as a product ID map. Okay, I hope till now everything is clear. And then I'm going to have this variable called product IDs, which is a collection of string which will have basically appending all the product IDs together, ID by ID into product IDs. Now I know that my getProducts function from my catalog client takes in product IDs and returns all the list of the products that have been ordered. If there's some issue, we'll say for that account, sorry, we were not able to get products. Then I create orders, and I take my account orders and I range over them. And this is for the protobuf only. I create my order for the protobuf, which is this order, which has the order product and all these details. So I create my order, where products is a list of order product, which is this order product, okay, and also my created at and all of that stuff as well. And it's good that I'm explaining this to you, because now I can see this small issue here which I've now fixed. So here you get the created at value as well, and then we'll range over all our products in the order, and one by one we'll have that available in our product. We'll extract the name, description, product price, all of that, and we'll check ID by ID. We'll compare that, and then we'll create our order products collection by appending to the order products the order product, and then we'll append that to the orders, all the order products, and then we return that in the orders for get orders for account response. So if you go to get orders for account response, that takes in orders, right? And each order, as we know, has two things: order product and the details of the order, and that's what we need. So in the orders we have all our order products and the details of the order as well. Awesome. So this is what our server.go file was about. Now we have to work on the client.go file, and then we'll fix the issues in this project. We're going to start with our client.go file, and before we do that, just want to remind you about the 6 AI plus Golang projects course that I've put on Gumroad. The link for this is in the description of this video, and we in this course we've built 6 killer projects. So if you like today's project, you will love these, especially the last one, which is almost 9 hours of building a terminal AI assistant, and each of these are, I think, 3 to 5 hours each, where you build a Kubernetes AI assistant, Terraform AI assistant, just to you'll get to learn how to not only work with AI APIs, but also how to build production level applications, how to handle errors properly. So I've put a lot of effort into this course. If you do get a chance to check it out. All right, now back to our client.go file. So in my client.go, this is part of package order. We're going to import a few packages here, and first things first, I create my client just to make sure I had created my main.go file also. Yeah, okay. So I think everything is ready, like our db.docker file, app.docker file, order.proto, repository, server, service. Everything seems to be ready. Client.go is the only file that's left. So let's go ahead and do that. So the first thing is connection, which is gRPC.client connection, and then it comes the service, which is order service client. And here in the server, I'm not sure if I did make that change. In server.go, here, right, for register order service server, we are supposed to make that change, if you remember, from the catalog. I will open up the server.go file, this little change, right, in the gRPC server struct. And here, instead of catalog, it will be order. And when you're calling the gRPC server, that's where also we had to make this change before the service. Inside the gRPC server. Yeah, but instead of catalog, the only thing is it will be order. And if you notice here, it's service that I've made equal to S, so I'm going to do that here, and account client will be equal to account client. Just for consistency's sake, I mean, it doesn't make a difference, but just for consistency's sake. Okay, so that's our server.go file. Now just making sure it's ordered everywhere, there's no catalog by mistake. Yeah, that's order service. Okay. So now we can be assured that everything should work now. Returns a client because it's a new client function, supposed to return a client. Dial the gRPC server, red and secure. So returning client, as we mentioned, that we'll be returning client from this function, which has the connection C, which is the client, and then a function or a method rather, to close connection to the client. And then finally, our two functions. One function is, as you remember, the post order function. It's going to accept some values, return some values, and it is a struct. And yeah, so these two functions, so let's go build them one by one. The post order function takes in context, account ID, and to create an order, each order, as you remember, has all the products that have been ordered in that order, right? And the order that gets created will be returned from this function. That's why we have we're returning an order from this function. And first we create proto products, which is pv.post order request order product. And now let's range over the products that we've just received, which are basically the ordered products as part of this order, which you just received. That's there in the products variable. Has a product ID and a quantity. And essentially we want to call the function that we already have in the service, which is accessible with the help of c.service.postOrder. passing the context and post order request, account ID, products, photo, products, and whatever. So when we call this function in the service, we'll get back a response. The only thing is this should be a round bracket. Something seems off or not. No, everything is fine. Okay, then here we have if error is not equal to nil, return nil, comma error. Now let's create a new order. A new order created at field, which will be equal to time from the time package. And we'll unmarshal this. And finally, from this function, because we want to return the order, so we'll say return ampersand order. Just put this on the other line. Okay, so this is the post order function. All that's happening here is we are accepting context, getting the account ID, because to create an order you need an account ID and the products ordered by that account. That's how you create an order. And you return this order that we'll just create right now. And essentially all that we have to do is this. This is the main part, along with the error handling. This is the main part where we are calling the post order function in the service, and all we're doing is passing the products and the account ID, right? Yeah, that's it. That's but we have all of that in the proto products, as you know, and then to return the order, we receive that. So once we create the order by calling the service function, this is R will have the order, and that's how we get access to the new order, and then we add this timestamp, and then we create the new order, and we return this from this function. Now get orders for accounts. What's supposed to happen in this function is you send this an ID, because this is getting all the orders for an account. You send this an ID, and you'll get back all the orders, or collection of orders basically, right? So what you're expecting is a collection or a slice of orders, and what you're sending to it is firstly its context and account ID. And essentially you have to call the same function at the service level, and you want to pass pb.get orders for account request, and what you get back is the response. create a collection of orders. And now we'll range over all the orders that we received by calling this function. At the service level, we get back all the orders, which is part of the response, and they're in the orders. And what we're going to do now, so each of these will be available to us in order proto, and we'll create a new order is equal to order, and this has firstly an ID, order proto.id, comma total price, order proto.total price account ID, which is order proto.account ID. New order dot created at dot on, just like we did in the previous function. And since each order has a list of ordered products, so we want to, because we're running all the orders, right? So we'll have to create a list of the ordered products as part of those particular orders. And we'll range the order proto.products ID, quantity, name, description, and price. So that's our client.go file, and I think we also have all the packages. Why don't we have the log package though? We've used it, and I think we've used it. No, yeah, we've used it, so why don't we have it here? Okay. Okay, so this works now. So it's time to now run run this microservice, and all I need is the Postgres error. So there should be no Golang error. There should be only that one little issue which it should say that cannot find authentication for Postgres, something like that, which basically means that Golang works fine, but I don't have the linking for Postgres, which is fine because that we'll create with the help of Docker. We'll start Docker containers. So that's what I am looking for. So here, the order microservice, there's a CMD folder, and there's another folder called order inside it. And here we would say golang.go. Supposed to fix all these issues. Okay. So client.go 68. So like many issues in client.go which we just created, and many issues in server.go. So client.go line 68. Let me see. Okay. This line looks, oh sorry, there's no blank character here. That's the issue. Okay, then it says line 73 expected something else and got something else. So what does that mean? This shouldn't be an issue, right? Is it happening only because of this? Maybe. Line 74 also something like that. It's saying, let me run it again and see. Yeah, so everything went away in client.go. Server.go line 51. Okay. What is the issue here? Is it just because that was on the other line? That was the only issue? No, I don't think so. It should be something more, right? So we have the post order request, post order response, and error. But everything looks okay to me. I don't get it. Yeah, that was the issue actually. Okay, server.go line 92. Okay. Here, right? It's saying there's some issue here. Order total price. What is it saying? It's saying missing comma. Oh yeah, missing comma here. Okay, all right. Let me see, is it gone? It's gone. Okay, now let's go to service.go. Service.go, it says non-declaration blah 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 line 39. Okay, is this also just because of the space? Yeah. So now we have a lot of issues coming up here. So server.go line 16. Sorry, line 19. Server.go line 19. So totally unrelated, I found that I have not given this the name as account, because I am referring to it as account here, but I have not given the name account and catalog. Okay, service and line 19 and 24. So the reason that service is not defined is because here it should have been capital S in service. So now that I've made it capital S, those issues have gone away. Now it's saying undefined gRPC client.go 18 line 18 undefined gRPC. Why would that be? Oh, I got it, because it's GPRC, not gRPC. Okay. All right. So that issue also fixed. It says cannot use repository.go 125. But it's saying cannot use quantity variable of type int as uint. Okay. Okay. So I have a quick fix. What I can do is I can just should I run it again? Okay, so now server.go s.catalog is undefined. Server.go line 60. Yeah, that because it's catalog client, it's not catalog dot client. All right. Now it says p.name is undefined. Server.go line 71. p.name. Yeah. Obviously, because this is p.name, capital N. Then it says o.created@at is undefined. Okay, server.go. What line is it? Line 144. Yeah. I'm sure you can also tell the issue is just should have been capital C. Now service.go line 48. What does it say? It says total is undefined. It's because it should be total price, not total. And now what happens is it works perfectly fine. It just says password authentication failed because obviously we are not running a Postgres server at the moment. So this microservice also works perfectly fine. So now you saw me write really shit code, like without a lot of planning in terms of writing code. We did a lot of planning in terms of product, like in terms of the approach, but not in terms of, I wasn't very careful basically while writing code. And what you saw right now is the compiler helping us fix everything, right? The compiler helping us fix everything. And that's what's the most important. When I say shit code, I don't mean like code that's not high quality, like this is really good code, obviously. What I mean is like, I wasn't very careful, right? I was making a lot of mistakes on the way. All right, now all we have to do is fix GraphQL and then we're done. That's it, that's the project. And I'll just run it quickly on Docker Compose. Okay, yeah. So I will actually copy and paste the Docker Compose file. Whenever you have to build Docker Compose files, I would suggest using ChatGPT. If you're not into DevOps, just use ChatGPT. Actually, even if you are into DevOps, just use ChatGPT. What's happening here is we have our first service, which is the account service, dependent on this database, the Postgres database. So it's a very, very straightforward Docker file because we have these multiple services, right? We have the first account microservice, the catalog microservice, which has a database running on 9200, which is the Elasticsearch port. Then you have the order microservice, which is dependent on the database URL, of course, but also on the account service and the catalog service, which are both running on 8080. And then you have our GraphQL. We have our GraphQL server. Then we have the databases. So the account database, which is a Postgres database, catalog database, which is the Elasticsearch database, and order database, which is the Postgres database again. Okay, so that's it. So everything will work perfectly fine once we just fix our GraphQL quickly. So let's do that. So essentially what I'm looking for, what I want is that I should be able to go into the GraphQL microservice, like the GraphQL server, and I should be able to say go run dot, and this should ideally start off the GraphQL server. Even if it doesn't say anything in the terminal, that's fine. I should be able to go to the browser, and the GraphQL runs on, as you know, localhost 8000/playground. So I should be able to see the playground right on my browser. That's what I want, and there should be no errors in the at runtime. So for that, I'll go here and I will now start making all of this uncommented, and when I saved it, it got me all the right packages, which is perfect. I'll uncomment all of this, uncomment this, and now looking back, I think I should have created the GraphQL server at the end, because it's it's obviously dependent on these things, right? So even if I'm commenting things out, I was not able to run it. So like, looking back, obviously, you know, everything makes sense, but when you're building it, things don't make much sense. So now I can see that there are some errors, but I want to confirm what the error is. So here I get all my errors. So it says cannot use mutation resolver, blah 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 blah. Let's figure it out. Yeah, I understood. The issue is that I have not implemented, it says, the create account method and all of that stuff, which I know that I have to first finish my query resolver and mutation resolver, so I have to finish those. Models and main.go file looks all right to me. So once I do these, and account resolver, of course. So once I do these, that's what it's talking about. It's talking about orders as well, right? As you can see, missing method orders, this one. So I'll just finish all of these. Let's do that together, and then let's try running the GraphQL server. So what do we start with? Let me see. What's the right file to start with? I think I'll do my query resolver first. That's what I think would be the best thing to start in the beginning. So I will first uncomment this and also uncomment this, and my query resolver for accounts. First, let me see if everything that we had written was all right. So everything looks okay to me. And start with context dot with timeout of 3 seconds. Sorry. And then defer cancel. Okay, so now that we're done with the boilerplate stuff, let's start with this ID that we've received in this function. So I'm going to check if the ID is not equal to nil. That means you want to get a single account, right? So the accounts query will be able to get a single ID, a single account, or multiple accounts. So here we're checking if the user wants a single account. That means he sent an ID. That then we will call the server account client dot get account. And by the way, these functions we have already built together. And if there was no error while running this query at the account client, sorry, if there was an error, we will log out the error and also return it from this function. And then so this is if the person wanted like a singular account, but what if they want multiple accounts? That means they will have that pagination details like skip and take and all of that. So let's do that, skip and take. And we have to call the get accounts function. I'm going to say ctx, comma, skip, comma, take. And we'll, once we run this, right, we get back our account list, or we get an error. And if there's an error, we'll handle it. Then we'll create a collection of accounts because that's what we're supposed to return from this function, if you remember, collection of accounts. Let's range over the account list. And append that to our accounts collection. Finally, return the accounts and comma nil. So that's our accounts query, and then we have our products query, and this also receives context, pagination, query, ID, exactly the same that we did with accounts. Start with the same thing, and I'll also copy this function and just make the changes that are required. So here, instead of account client, I'm just gonna call the catalog client, and instead of account, it's get product, and instead of account it is product, and the values that we'll have will be description, which will be r.description, price, r.price, and the same skip and take thing we did here for pagination. Now for products, you might also have a search query, so I'm gonna also handle that. And just like we got our account list, we are gonna get the product list. So here it's going to be called product list, and here it's going to be the catalog client and the get products. Just making sure, because I've copied and pasted stuff above, also just making sure I didn't do anything wrong. I think it looks all right at the moment. All right, and here, instead of the account collection, we are gonna have the product collection, but the code is going to be slightly different. So I think I'll just write it from scratch instead out here, just being careful, right, to avoid errors. So we'll say var products, and for a range product list, and then finally we've been calling this bounce function. So I want to go ahead and create that function also. So func pagination input bounce, it has skip and take. And we'll return skip value and take value. So that's our query resolver, and next we have to build our mutation resolver. Yeah, I have that option, or I can also work on account the account resolver. I think I'll do the account resolver first, and then I'll do the mutation resolver, and then we're done. Mostly we're done. So let's work on our account resolver now. Account resolver. Okay, now let's check. So account resolver, basically the job is to take an account and return all the orders for that account. Okay. Now the best part is we're going to copy some stuff from here. To start with, and then we get our order list by calling the server level from order client function called get orders for account, and the order object has the ID because we want to get all the orders for that particular account, so for that particular account's ID. And then we want to handle the error, so the error handling is also the same like this. So let's go ahead and copy and paste this here. Now we want our list of orders that we want to return, our collection of orders, and for that we have to range over our order list being this object here. And each singular order is available to us in O. Let's create a list of ordered products. And range over our order, and each order, as you know, each order has multiple products that make up the order. So that's why we are ranging over all of the products from O, which is each order. So we were ranging over all the orders in the order list, and for each order we have multiple products, so we're ranging over all the products. We have access to them with the help of this p variable, and we're gonna append them to the products list. And this has multiple fields: ID, name, description, we have price, we have quantity, and ID, p.id, name has p.name, description has p.description, price has p.price, and quantity has integer p.quantity. Once we have accessed all the products, added them to the products list. We now have to append all these orders to our order list. That's what we have to do now. Finally, obviously, from this function, you have to return orders. And here, you have to create your orders list by appending to the orders list every single order. And each order will have ID, will have created at, it will have the total price, I'll have the list of the products which is available to us in products. The total price is O dot total price, created at is O dot created at, and ID is O dot ID. So this is our account resolver. We've done our query resolver already, and now we're left with our mutation resolver. So let's work on that. So the only remaining thing now is our mutation resolver. Mutation resolver, I'll first create quickly an invalid parameter error. And I'll uncomment all of this. And here, in our create account, we are taking in context and an account input. And what we'll do is we'll use context dot with timeout, same 3 second. And defer cancel. And what we'll do is we'll basically call the post account method. So in case you don't know what GraphQL, how GraphQL works, all the things that can edit the state are in mutations, like creating new stuff, and querying, like reading from the database, are in the query resolver. Okay, so now the handling error part, I'll just copy this. And finally, because we have to return an account, the account that was created, we have to return that to the user. So we're going to say account ID comma name. And remember, our only aim right now is to somehow start the GraphQL server so that the GraphQL playground opens up on our PC. That's it. And then everything is fine. And now the next is the create product mutation resolver. And same 2 lines. Copy them here, and just to save time, I'll copy them here as well. And instead of the account microservice, you have to call the catalog client. And instead of post account, you just have to call post product. And you're passing multiple values like name, description, and price. Instead of A, it will be available in P. Now handling the error part, get it from here, and then we have to return the product. So instead of the account, let's return the product. And what all does the product have? It has name ID, it also has description, it also has price, And then you have create order. First we create a list of products. The create order, as you know, order has multiple ordered products as well, along with the account ID with which the order is associated. So in the input that we have received in this function, there are these multiple products, and you want to check for quantity, because if it's less than 0, then it's an issue. Because to place an order, you have to have like multiple quantities, right? At least one. And then I will just copy this line, this part here. So instead of post product, we're gonna have post order. It's gonna have the catalog client, we're gonna have the order client. Instead of P, we're gonna have O. And instead of all this, we're gonna have the list of products and in dot account ID. And finally return. Oh, here see one problem that's there is P. Well, this should have been P. So when you copy stuff, right, you're just asking for trouble mostly. So I always recommend to not copy stuff and just type things on their own or on your own. But what happens is when I type everything from scratch on my own, always, I get a lot of hate in the comments. People say, hey, why are you typing stuff from scratch? Why can't you just copy it? This is the reason, it just compounds your the number of errors that you have. That's the whole reason why I don't copy. But anyways, it's done now, and I will now fix all these issues that it's showing. Okay, so mutation resolver, line 59. It's saying, oh yeah, I didn't put a 0 here. That's the problem it has. Okay, no problem. Undefined, blah, 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 blah. Okay, mutation resolver, line 20. Context dot context. Oh, everywhere I made that same mistake. How's that even possible? What about query resolver? Have I made the same mistake there? No, not really. Anyways, so query resolver has some different type of issues, and similarly with account resolver also. Line 23 account resolver. Let's see what it's saying. Okay, yeah, this should be multiple, right? Orders. Now some issues should go away, hopefully. Graph.go line 44. Okay, what's the problem here? What is it saying? Mutation resolver does not implement mutation resolver. Now that I look at closely, it says create account, create account with the capital C. And that makes sense. That makes sense. The mutation resolver makes sense. See, you can be a complete idiot like I was when I was writing this code. And look at the beauty of Golang, the compiler. It's not just telling me what the issue is, it's telling me how to fix it. Exactly how to fix it. I mean, I don't know, like obviously Rust also helps you do this. I don't know any other language that is this good, right? Okay, query resolver, line 38. So this is why when people from JavaScript background or Java or any of those languages background, when they watch my videos, they get like very, very anxious. They think, why is he writing all the wrong code? Can't he just see this issue? When I'm watching the video, I know that this issue is there. That's what they think, and they think, oh, why is he not fixing all these issues? Because of this, I don't care like if there's any issue, because I'll be able to fix it very, very easily later on. Anyways, line 38, account declared and not used. Okay, line 38, account declared and not used. Yeah, and that makes sense because this should be accounts, right? If you're creating collection of account, then should be accounts. Okay. So many of those account related issues have gone away. Now we have query resolver, line 44, cannot use append. Okay, why is that? Yeah, of course you can't use append because it should have been accounts in the first place. Can't use append for account. That also makes sense. And now you have queue declared and not used, line 72. Query resolver, line 72, queue is not used. Because here by mistake I've written 1, should be having queue. Okay, so that also gets fixed. And then again line 72, why I just fixed it, right? Queue is like, I just used queue, right? What's the problem? Didn't I save it? Oh, I didn't use it in the sense, yeah, see, this is why you should not copy stuff, because I copied this get accounts part from here, but I didn't like change this based on the get products function, which is nil NQ. I had to add nil NQ here. I think I must have made that kind of a mistake in account resolver also. That's what I think now. But everything looks here okay. Let's see. Anyway, so query resolver, I fixed that. I used queue there. Now what happens? Failed to exit idle mode, pass through received, empty target in build, exit status. What is that? What does that mean? Okay, I think I'll have to regenerate these GraphQL files for this issue to go away. Before that, I will also create my app.docker file, which I realized I have not created here. So I'm gonna go ahead and create that anyway. So what I'm gonna do is I'm gonna generate, I've deleted my GraphQL files from here, and I'm just gonna run GQL generate. GQL generate. Sorry, this is the actual command. Go run github.com/99design/GQL generate. Okay, so will I have to get this package again? So I struggled a bit with it, and finally what worked was I had to remove the vendor folder. And then I ran the go run github.com/GQL generate command, and then it worked. And here now you can see my generator.go file and my models.gen.go file, and now everything will work perfectly fine. So I'll just clear everything out, and now let's run it. So nothing is showing up here. That means no errors are there at least. And what I want to do now is I want to go to the I need to go to the browser and check the playground. So this is awesome. The playground is working. Our GraphQL playground has opened up. That means the GraphQL microservice is also working. So all the microservices are working. Now it's time to run the Docker compose to see if everything works perfectly fine. So I'll stop this and I'll run Docker compose. So what we need to be running is the Docker compose up build command. Let's see if everything works perfectly fine. Okay, so all our microservices are working fine. Now it's time to play with the microservices. The first thing I want to try is querying the accounts. Okay, so it shows There are no accounts, perfect, because we haven't created any. And now I'm going to run a mutation where I want to create an account. The name will be new account. So I'll just note down this ID. And somewhere safely I will note it down. Okay. And yeah, so I've noted down my account ID, and I will now create a product also. So I will note down the product ID as well, and I will also query the products to see, yes, one product is coming up, so that works perfectly fine. Querying the account, does that work? Yes, querying the account also works. So creating account, creating product, querying account, querying product works perfectly fine. Now we have to create an order. Now creating an order is a bit tricky because you have to put the account ID here. So my account ID that I had was this, and my product ID that I had was this. Just a second. And see, we have quantity also. So we have like a quantity for the products. And now I have created an order. So this is my order. Okay. So now I'll query account with orders. So what I'll do is, for that particular account, I want to get all the orders placed. So I will enter the account ID that I noted. Awesome. So I'm getting the product that I had, products, which is the new product, and quantity 2. So this is the order, right? And this is the order ID for that particular account. Okay, now we can run some advanced queries also. The one with pagination, and search term can be new because all our products are called new products. So yeah, so a new product showed up, and we'll calculate the total amount for the product ID, the account ID. So I will enter the account ID here. Total price is 39 because we ordered multiple items, right? 2 items or something like that. Okay, so this is it. Product works perfectly fine. I will now upload this to GitHub, and yeah. So I'm Akhil Sharma 90 on GitHub. So you will find this project there if I forget to add the link, because like I said, you know, I'll be creating this project and I'll be uploading it in after it's edited. So just make sure you check out my GitHub. The project should be there. Thank you so much for watching, guys. I hope you enjoyed this. This took me a long time to build, right? It's like, I don't know, more than 5 hours or something since I've been building the project. I hope you appreciate this kind of stuff. I have more microservices stuff coming up, and I do this for you guys. I do this so that I can share my knowledge. Yeah, do check out Armor, do check out my course, and do check out the Discord community that I showed you. You know, come get in touch with me. We'll hang out on the Discord community. All right, thank you so much, guys, for watching, and I will see you in the next video. And yeah, thank you so much for your support.